Good morning, madam.
Good morning. Good morning, Vijali. How is everything going on?
Fine.
Good, very good. Yesterday I could not join so, because some of my students' thesis checking out is going on. So, um, anyway, so today is second day.
Okay.
Can you hear me, Vijali?
Yes, madam.
Okay, then everything is okay.
Show me. Let's start.
Good morning to respected eminent speakers, organizing team, and participants. Welcome to 5-day online faculty development program on recent trends in civil engineering, organized by Department of Civil Engineering, Haldia Institute of Technology, Haldia. As said by Dr. APJ Abdul Kalam, the ignited mind of the youth is the most powerful resource on the earth, above the earth, and under the earth. FDPs provide an excellent opportunity for all faculties and practicing engineers to revise or rather reignite the flame of knowledge. So let us start today's session with this thought. To introduce our speaker, Dr. Anjali Pal, Professor, Department of Civil Engineering, IIT Kharagpur. Madam has earned her BSc with honors in chemistry, MSc and PhD in chemistry from Calcutta University. Professor Pal has an academic and research experience of 30 years. Her area of research interest being pollution abatement and environmental engineering, synthesis and application of nanomaterials, catalysis and spectroscopy, analytical chemistry, and natural product chemistry. Dr. Pal has published more than 350 technical papers, which includes international national journals and conferences, and served as principal investigator and co-principal investigator for a number of sponsored research projects. Madam has collaborated with a number of foreign institutions on invitation. Dr. Pal has served as editor, co-editor, and member of editorial advisory board for a number of reputed journals, besides being reviewer for many ACS, RSC, Elsevier, and other international national journals. Well, I welcome you, ma'am, on behalf of the entire department. We are really overwhelmed to have you here. So, thank you, ma'am. Over to you.
Thank you, Dr. Rajwangshi, for your nice introduction. And I must thank Dr. Bijali Mondal, actually, who is a student here. She did master degree, MTech degree from here, and during that time, I was associated with her project work, and she's very favorite student. She's my favorite student, very sincere and very caring. So as soon as she invited me, I said surely yes. So I cannot say no to you, and I am here to tell something about my work, and it is very much relevant to our daily life also. And because the audience is I think research scholars, and then some college teachers, maybe it is FDP program, faculty development program. So I will tell my talk today. I will tell in a very lucid way and very simple way, so that everybody can understand and find some interest. Okay, if any point of time you feel that it is not understandable, please let me know. Okay, I will go in simpler way. So today, so can I start? Can I start now? Time is still 5 minutes, I think, is there. So
Yes, ma'am.
if you tell, I can start, no problem.
Yes, ma'am, you can proceed.
Okay, thank you. So let me share my PPT. Can you see the screen?
Not yet, ma'am. Yes, it's visible now.
Is visible?
Yes, ma'am.
And you can hear my voice also?
Yes, ma'am.
Okay, so then I can start now. You can see the topic, the title of my talk. It is soap, detergent, and micelle and their application in chemistry. So I am here. Actually, I have just retired. In 30th June, I retired from my department, but I am associated there for maybe more than 25 years, and this is my means favorite department, and I worked here. I developed many things here. Today, I am feeling real sad because I have attached, but officially I am not attached. Anyway, so that is the light, no problem. Um, so I will tell you first that what is soap, what is detergent, and what is the difference between them. Everyday life we use soap, we use detergent, and this is something which will be produced from both soap and detergent. Many of us do not know that what is the difference between these two, what is soap and what is detergent. Okay, for practical use we know that soap we use for bathing purpose and detergent we use for cleaning purpose. But chemistry point of view, because you can see here this is chemistry part, some of the chemistry I will tell. So what is the difference between these two? um, the soaps, soaps, I will tell you the chemical structure, basic chemical structure of soap. That is nothing but this one. This is a carbon chain, long chain, carbon, long chain carbon, okay, and then maybe 17, maybe 18, maybe 19 carbon atoms are here. And this, in chemistry we always write CH3, CH2, 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 something like that. We write in this fashion, isn't it? So this is basically a chain and carbon chain, and here this is the difference here. In the soap, actually it is the carboxylic acid group, COO minus, and sometimes sodium salt, sometimes potassium salt. Um, it is the means corresponding cation, okay. But you can produce silver soap also. If instead of sodium or potassium it is silver plus, then it is silver soap, okay, silver soap. Now, sodium and potassium, what is the difference? Potassium soap is softer and sodium soap is little bit less mild. Okay, that is the difference. But otherwise, the property of both sodium and potassium salts of carboxylic acid is same. What is the property I will tell you, but before that, let me tell you what is detergent. Now, you see here, these are all the detergents like Surf Excel, Nirma, Dhori detergent, Clinic shampoo. These are all detergents. But what is the difference of the detergent with the soap? Here, if we go to the structure, we will see that this is called, actually, this is the carbon end. It is, that is why it is the hydrophobic end. Hydrophobic, carbon does not like water. That is why hydro means water and phobic means hating. We know hydrophobia, right? That disease. So hydrophobic means it is not liking the water. And this part is hydrophilic. That means philic means loving. So this part, this end likes water. So this is the characteristic of the surfactant. So both detergent and soap are nothing but surfactant. Okay, so what is surfactant, that I will tell, but first I will tell you that detergent, what is the difference of detergent with the soap. Here actually this hydrophilic group, which is also called the head group, this is called tail group and this is called head group. The head group is not carboxylic acid. It may be sulfonic acid or sodium salt of sulfonate, or it may be some quaternary salt like this NR3 plus, okay, but not carboxylic acid group. That is the difference with the detergent. I will show you the structures, but just for the timing, you know that this is the main difference with the main difference between the soap and detergent. Now here you can see that soaps and detergents, they are used in pharmaceuticals, they are used in personal care products, okay, and in many industries like textile industries, paper industries, polymer, oil refinery, metal processing, food industry, everywhere it is being used, and that is why we can see that many industrial wastewater it is coming even in the surface water like the river water or pond water. You will see lot of surfactants present, lot of detergents present, lot of soap present, okay. So that is why civil engineering job is coming. Civil engineering people had to take up this, have to take up this challenge, that how will you clean it. If it is coming to the environment, then it is your job to clean, it is our job to clean it. How to do it, that I will tell, but a little bit, but initially I will just tell you the. So these are the compositions, main compositions. So Colgate Plus, you will see lot of CAs. Then these Life Boy and Clinic Plus, lot of CAs. And laundry cleaner, mostly A's, anionic surfactant. Then Surf Excel A's. So mostly the detergent powder that we use for cleaning purpose, cleaning our cloth, is mostly the anionic surfactant. And anionic surfactants are, what is anionic surfactant, what is cationic, and what is non-ionic surfactant, that I will show. But before that, let me tell you that what is the that laundry detergent that we use every day for cleaning our cloth, what is the typical formulation. Typical formulation. So surfactant is the major part, as you know, that is the anionic surfactant is major part, then non-ionic is also there, then little bit soap may be there, then builders. What is builder? Builder is something which will increase the efficiency of the surfactant. So what is that? There may be some polyphosphate, some sodium carbonate, silicate, all those things may be there. They will vary. So from company to company, they change the formulation little bit, and to increase their efficiency, and they will not disclose it, but these are the main composition, okay. These are the general composition. Enzymes, some enzymes they put, say for example bleaching agents, some flavors they can add, brighteners, stabilizers, all those things they can add. And because sometimes you know when so for example a blood stain is coming, so to clean the blood stain, it is an organic compound, so to remove it, sometimes enzymes are very useful. That is why they put some enzymes. I remember one thing, this is a practical experience. A few months back, I had some itching in my hands, okay, and also in my skin. So some eruptions and all those things started. So I told that what is the problem. Then somebody told me that you change the detergent, you change the soap. Okay, maybe something is there in the detergent that is creating some harm in your hands and all. So why it is so? Because we do not use the same detergents every, sometimes we change, right? So some, and we do not know exactly what is the formulation. So something may be there which is not suitable for your, which is not good for your skin. That is why it may create some problem. Some allergic may come, some eye irritation may come, some itching may come. So those things are the direct effect on our health. Okay? But there are some indirect effect also. Say for example, simple example, say for example, in a pond, lot of people, they wash their clothes, okay, and then some surfactants are come, some detergents are coming there. Then when it is coming there, so if there is some other compound, say for example in pond water there may be some pesticide, okay, some runoff water may contain some pesticide and it will ultimately may come to the pond or river, okay. So in that case, because there is some surfactant present, so what will happen, they will create some different environment for the pesticide. And in that case, pesticides or other not only pesticide, it may be anything. So so I'm taking the example of pesticide. So for example, a pesticide which has lifetime, say half life is say 10 days, okay, and it will, some natural degradation will take place when it is contaminating water, say after 10 days or 20 days, it will it will vanish, okay. But because of the presence of the surfactant in the medium, it may not, it may have more half life, means more, its half life may increase, okay, or, and also it may not vaporize. So it will be stabilized, means the molecule will be stabilized by the surfactant. In that case, it is indirect effect. So so you see that natural degradation procedure will be hampered. So this is the indirect effect of surfactant, and direct effect is of course health. Now here you can see that this is the most important part, characteristic of a surfactant. What is the meaning of surfactant? If you see the word, you can divide it, surfactant. So surface, from surface it is coming, surf, active, acid, active agent. So it is basically surface active agent. For common people, they will not understand what is surface active agent, what is the meaning of it. So I will tell you what is the meaning, but before that you can see the property of any surfactant. It may be detergent, it may be soap. So what is the property? If you put sufficient amount of this compound in water, then this type of aggregate will be formed. So the specialty of the aggregate is that you can see that the carbonates, because it is a water medium, so carbonates that which are hydrophobic, they will come together, and the hydrophilic ends, they are polar groups because they are ionic groups, so they will come towards, they will focus towards the water because water is polar. So this is a aggregate, this is called aggregate, dynamic aggregate. Why it is dynamic? Because it is not, it is forming and breaking, forming and break, of course it has some lifetime, but it is not, once it is formed it remains like that, it is not like that. Anyway, so it is shown in a two dimensional way, but basically it is a three dimensional figure. It is a ball like structure, ball. So in the ball, if you remember, if you think a ball, in the ball inside part is hydrophobic part because carbonates are all coming together in the inside, and the hydrophilic parts are outside. So inside is hydrophobic and outside is hydrophilic. So it is a very unique structure. Why it is unique? Because there are some molecules which are hydrophobic. Say for example, simple example is benzene. Benzene is C6H6. There is no hydrophilic groups there, only carbon and hydrogen. So it is a very hydrophobic molecule. So if you take water, if you take water and if you put a very small drops of benzene inside the water and shake it, you will see some micro emulsion is formed. Emulsion is formed. Why emulsion? Because benzene is hydrophobic. It will not be solubilized in the water medium. In the water, it will form. It is insoluble, so it will form this emulsion. Okay. But if you put some surfactant there, and with a sufficient concentration, if you put benzene now and shake it, you will see it is solubilized. Why it is solubilized? Because in the water there is the surfactant, and once the surfactant is there, they form this structure, and inside part is hydrophobic, so benzene will come inside and it will become solubilized. This is the same principle that we use for our cleaning cloth. Why? Because you know that when we clean the cloth, that means dirty cloth. So in the dirty cloth, what is there? In the dirty cloth, mainly oil and grease is there, dirt is there. So oil and grease is coming from our skin or body. Okay? In our body there is oil, so that is coming in our cloth. It is making it dirty. Now, this oil is not soluble in water. This is like our, say for example, cooking oil. Okay, if you put 1 drop of cooking oil in water and mix it, it will not mix. It will not mix with the water. It will not be solubilized. But if you put some surfactant there, then it will be solubilized, just like benzene. Now here in our cloth, lot of, this is fabric, so cloth, there is lot of grease, means oily material. Okay, that will, if you put it in simple water, it will not come into water. Why? Because it does not like water, it is a hydrophobic molecule, it will remain there in the cloth. But once you put surfactant there, then the surfactant will solubilize the oil and it will bring it to water. Then you throw the water, then it will go out with the water. That way, our cloth is becoming clean and becoming free of the oil and grease. Okay. Now, here you can see the, I said that some concentration is needed, because at any concentration this type of micelle, it is called micelle, 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 or micelle, some people call micelle. So this is formed above a certain concentration. Okay, that is called CMC, critical micelle concentration. When it, the concentration is below critical micelle concentration, then this type of aggregate will not be formed. So this is the something like this. This is beaker. This is a beaker, and in the beaker there is some water. This is the surfactant molecule. Now, when you put very small amount of surfactant molecule, then it will dissolve in it, but it has two different parts. One is the head part and one is the tail part. So it will be in the interface. This is the interface. Interface means it is the boundary between two phases. Here it is the air phase, and here it is the water phase. Because the concentration is very less, so what will happen, the hydrophilic, that is the head group, will remain in the water, and the other part, because they do not like the water, so it will remain in the air part. So it will form like this layer. Okay, and when you increase the concentration, slowly it will form a mono layer. It is called mono layer. Okay, so there are many molecules, so it is remaining in the surface or interface, and as you go on increasing the concentration, then it will form micelle like structure. Okay? And then it will be useful for cleaning your cloth. Maybe you have experienced also, when you put small amount of surfactant, your cloth is not cleaned properly. If you put sufficient amount, then your cloth will be very clean. So this is the reason actually. Okay, now I told you about the surfactant. There are many different types of surfactant. These are all detergent, detergent. They are not soap. Why? They are not soap, because you can see the head group here. It is not carboxylic acid group. It is sulfate group, or it is sulfonate group, or it may be quaternary ammonium group, or it may be some OH group. OH group is also polar. You know that this is the OH group, means it is the like hydroxyl group, like alcohol. Okay, this is also polar because oxygen is there, so it is polar, but it is not ionic, because here I have shown you that these two are both are ionic groups, but it may not be ionic also. It may be non-polar, it may be polar group, and it is non-ionic group. That also possible. That those are called non, means here you can see that I have shown you here. This is the non-ionic surfactant. So non-ionic surfactant is something like that, OH group. At the end there is some OH group. Okay, that is polar group, but it is not ionic group. That is why it is called non-ionic surfactant. But property is same. They will also form micelle. They will also have the cleaning action. Okay. Now I will tell you about, so you understand the property of surfactant. I will show you how we know in our daily life how surfactant is being used. Even in the toothpaste there is surfactant, no, and in shampoo it is surfactant. And many surfactants they have some antibacterial property also, like cationic surfactant. They have antibacterial property, and some surfactants they have some conditioner. As a conditioner it is being used. Cationic surfactant they are used as conditioner also. So this is the application in our daily life. But I will tell you how we can apply in laboratory. Okay, because I am talking about chemistry, and I am also from chemistry. So chemistry, how it can help the surfactants to overcome some problems, that I will show you now. Maybe you will feel interested. Now, when we started the nanoparticle research, that is in 90s, say 1995, 96, something like that, that time nanoparticle research was like infancy stage. Nobody knew what is nanoparticle, what we can do with it. But now, even in the colleges, they are producing nanoparticles. They are using it. They know gold nanoparticles, silver nanoparticles. Even school boys they know now nanoparticles, right? But nanoparticles. So, what is nanoparticles? Nanoparticles are very small particles. Okay, they are defined by their size. 1 to 100 nanometers. You know, nano means 10 to the power minus 9. So it is 1 to 100 nanometers, very small size. And the range is 1 to 100. Now I will ask you one question here. Say for example, I have now, you know, that nanosphere, nanoprism, nanorod, nanoware. There are so many different types of nanoparticles. Now think about a ware. Okay, it is a ware. Okay, the ware, think about the dimension. The diameter of the ware, say for example, is 50 nanometer. Okay, diameter is 50 nanometer, and the length, it is a ware, so it must be very long. So the length is, say for example, 1000 nanometers. Okay, so because it is defined by the size 1 to 100 nanometers, so when the size range is like this, then we will call it nanometer. But then what about this ware, whose dimension is like this? The diameter is 50 nanometer and length is 1000 nanometer. Should we call it nanoparticle or we should not? That is the question. This is a common question that is asked to the students, that this is a particle, so whether you should call nanoparticle or not. Actually, the definition is like that at least one dimension should be in this range, 1 to 100 nanometer. So this wire that I am just talking about, it has the diameter 50 nanometers. So this dimension is in the this definition is fulfilling. Okay, fulfilled. That is why this is also nanoparticle, but it is because of the shape we call it nanoware. Okay. Now, so nanoparticles, why it is so important? Because it has many applications. But the problem with the nanoparticle is this: they are very unstable. They are very unstable. Why they are unstable? Say for example, these are nanoparticles. Okay. Now nanoparticles, they are very small, so their surface is very, the energy, surface energy is very high. Okay, and if you keep it in some solvent, it will immediately, it will, you see, agglomerate. It will agglomerate and it will form clusters, or it will form bigger size particles, so it is no more nanoparticle. Okay, to keep it in its proper size and shape, we must need some stabilizer. What is the stabilizer? It may be some polymer, it may be some gel, it may be some solid surface, it may be some other stabilizer. Okay, so how surfactant can help to serve as the stabilizer, that I will tell you. Okay, so that means now I will show you a few slides where nanoparticles are produced, and to keep their size intact or shape intact, how surfactant molecules can be used. That is the few slides I will show that. Okay, now is his stabilization of nanoparticles. Maybe many of you are working with nanoparticles, silver nanoparticle, gold or TiO2 nanoparticle, or maybe other types of nanoparticles. So in school, in college, in university, everywhere nanoparticle research has started. Now here you can see that stabilization. So there are mainly this type of sterilization, the stabilization. Electrostatic stabilization, example is like that. So nanoparticles, if they are charged, we can make the charge on the nanoparticle, then two nanoparticles, they are having the same charge, so they will repel each other, so they will not come close, they will be stabilized. In that case, they will be stabilized, they will not aggregate. It is called electrostatic stabilization. Okay, another is that steric stabilization. Steric means, you see here there is no charge, but outside the nanoparticle there is maybe some polymer, say for example. So called polymer coating is there. It is coated with some polymer. Okay. Now when it is coated, another nanoparticle, it is also coated, then they cannot coalesce, they cannot touch each other. In that case also it will be stabilized. So as the some ligands may stabilize it, some surfactants can stabilize it like this, some thiols can stabilize, some amines can stabilize, some polymer can stabilize, some ionic, other types of ionic compounds, even the inorganic ions also can stabilize. Okay, so these are the stabilization. Unless you stabilize the nanoparticles, they will not be nanoparticles anymore. Just after producing it, after some time you will see that they will precipitate, and so that means that they have become bigger in size. Now this is one method of photochemical formation of gold nanoparticles. Okay, and stabilization, of course, by surfactant. I will show you. Okay, this is our method actually. So we did it in maybe 1998, 1990, a long time back. Okay, this is our initial research on nanoparticles. We have done it, and it has got many citations now. A lot of people have used it because it is a very reproducible method and very simple method. I will show you how we can do it. So TX100, TX100 is nothing but a non-ionic surfactant. And non-ionic means at the end there is the OH group. I have shown you already maybe this one. This is the structure. Here it is given n, so depending on n, TX100 or TX other numbers will come. Okay, but those are TX. So here you can see this is the oxy, this is oxy, and this is ethylene. So oxyethylene group. So poly means many such groups are there. That is why poly, and this is alcohol. That is why the name is polyoxyethylene alcohol. But this is basically some TX, maybe 100, maybe other numbers will come depending on the this value. Okay. Now So you understand what is non-ionic surfactant. Okay, now you see that how it can be used for the gold nanoparticle preparation. Okay, gold nanoparticles means AU0. You may tell that, okay madam, gold is very costly, but it is produced in very low concentration, right? For the catalysis purpose or other purposes, a sensor, it is produced in low level. So in that case, gold is not that costly. You should not think that it is very costly. So other metals also can be produced, like silver, palladium, they are also maybe produced, but here I will show you gold nanoparticle. Now, what is the beauty of nanoparticle? That I must tell you that when it is bulk, say for example, gold we wear, the gold bangles you wear, gold ornaments, gold rings we wear. Why we wear gold rings? Just because it looks nice. That is why, or other why we do not use silver rings, silver bangles. Uh, One reason is that silver, if you wear for say 1 year or something like that, you will see it has become black. It has become black. But if you wear gold, you will see that it is retaining its miss and that shining property. Okay, why it is so? Because gold is noble metal. Noble metal means it does not react with other things easily. Okay, that is why we wear gold rings. But if you wear say copper rings, it will be after some days you will see it has become black. It is noble, it comes in noble metal group, but it is not that noble as gold. Platinum is even more noble than the gold, but platinum is very costly. That is why we do not use the platinum for our ornaments. Now here, gold gold to dissolve the gold, you may have seen that to dissolve the gold in the where they make ornaments, you may get some very pungent smell. Okay, why you are getting that pungent smell? Because they are dissolving the gold. How they are dissolving? Because gold is very noble. So if you want to dissolve the gold, then it has to be made some gold compound, but it is very noble metal. So to dissolve it, you have to use a very strong acid that is called aqua regia. You have learnt it in your school days. Aqua regia. Aqua regia is very strong. It is basically a mixture of HCl and HNO3 in 3:1 volume. Okay, and that has the ability to dissolve the gold. Okay, even only HCl, only nitric acid cannot dissolve gold. Aqua regia is needed. But here the gold, the property of gold, if you can make nanoparticle, the property of gold will change when it is bulk. So for example, ornament, here it is gold bulk means it is not nanoparticle, many particles are together, so it is bulk metal, bulk. So if you think about bulk gold means gold 0 and gold 3. It is a common oxidation state of gold. Gold 0, gold 3. Then if you go to the textbook, you will see that the E0 value, that is the reduction potential, is very similar to permanganate. Permanganate means KMnO4 means MnO4 minus Mn2 plus. It is a very strong oxidant, right? KMnO4 and Mn2 plus, that system, it is also plus 1.5. So plus 1.5 means it is a very strong oxidant. And when it is minus, E0 is minus, it is a strong reductant. Okay. So what is an oxidant that will be reduced? Oxidant will be reduced and reductant will be oxidized. That from the school level, school chemistry. Now this gold, when it is bulk, then the E0 value is plus 1.5. Okay, very close to permanganate. Okay, So if you compare it with gold 0 in the nanoparticle range, gold 0 in the nano range, okay, this very small particle, that E0 value becomes minus 1.5, can be minus 1.5 even. Okay, what does it mean? So when it is bulk, it is plus 1.5, and when it is nanoparticle range, then it is minus 1.5. What does it mean? That property is totally changed. Property is totally changed, isn't it? So nobility, noble metal, which was noble metal, it is no more noble metal. So it can easily, it can be easily, it can easily react with other things, even oxygen, even oxygen. So when you can make gold nanoparticles, then even oxygen can dissolve it. Dissolve it means what? Gold 0 to gold ion it can form. Okay, so you can understand that nanoparticle whole property E0 value we know from school days. It is a very fundamental property. Redox potential is a very fundamental property. In the school book, in the textbook, you will see it in the table form. Okay, but now we see what? Now we see that bulk metal and noble, that nano stage metal, that fundamental property is changing, color is changing, everything is changing. Okay, that is why nanoparticle research is now very important today. Okay, now here you can see that gold, okay, gold, how here you can see gold chloride. Gold chloride means this is the gold chloride HAuCl4. This is the color. Now if you mix it with TX100 and then you put some UV light, then you can form the gold 0. Okay, gold 0. So gold 3 to gold 0. So that, and what is the function of this TX100? The function of this is that it is a reducing agent. Okay, gold 3 to gold 0, it is reducing and it is also stabilizing. So both function it is doing. It is a reducing agent and it is a stabilizer, and that way the gold sol is produced, gold 0 is produced, which is nothing but the nanoparticles. So see the nanoparticles, how good stabilized, how nicely stabilized it is, how nicely stabilized. You see, no two particles are jumbled up together, all are separated. That means good stabilizer. And you see here that gold, when it is a bulk metal, you see the gold color, but when it is nanoparticle, you see the gold color, it is pink color. It may be green color, it may be blue color, it may have different colors depending on the size and shape of the nanoparticle. Okay, this is a beauty of the nanoparticle property or research, whatever. Okay, now they are very good catalyst also, because they have small size. Small size means they have lot of surface area, so they are good catalyst, they are good sensors, they have many other properties. Okay, so that is why it is very important to develop methods, simple methods, good methods, reproducible methods to prepare the nanoparticles. Now you may tell, okay, so TX100, which has the group OH at the end, so how it is stabilized, how it is acting as a reducing agent. Okay, that is the question. So how it is acting? Because you know OH group, OH means it is CH2OH, right? CH2OH. So you know that CH2OH can be oxidized to COOH. We have learnt in the school also and in the college also, that CH2OH is a hydroxyl group, is an alcohol. It can be oxidized to aldehyde and then finally to acid, carboxylic acid. So basically OH group is converted to carboxylic acid. So it is oxidized, at the same time it is reducing the gold ion to gold 0. Okay, as very simple. And UV light, a tube light, very means maybe a 18 watt any 18 watt, even 6 watt. So they can produce the gold um, nanoparticle here with good stabilization, okay, by the TX100. So this is one very good method. It was related to this research long time back. You can see that we have done this work. So many papers are already published. Now, and how it is stabilized? How it is stabilized? This it is stabilized in my cell. You have seen my cell. So my cell, this is formed by the TX100 and the gold zero. It is inside the my cell, so it is stabilized. Gold zero is small particle, so it is coming inside the my cell, and it is getting stabilized. Okay. So this is the one application of nanoparticle, because my topic is nano. My topic is the application of surfactants. So it is an application of the surfactants to produce the nanoparticles, to produce gold nanoparticles. Okay. Now I will tell you something regarding the. It is another application of surfactant for the arsenic determination. Okay. So the topic is, you can see here, spectrophotometric determination of arsenic via nano gold or nano silver formation in micellar medium, and gadget method. This you know, all of you know, whoever is there in environmental engineering, they know gadget method. It is a very popular method, and it is in the standard method book also. This is a method, spectrophotometric method for arsenic determination in parts per million level. Okay. Now, what is the method? I will tell you little bit, but before going to that, you know, arsenic, the arsenic pollution was there. It is mostly natural origin, but geogenic origin, and you know, all of you know the effect of arsenic. You see, after a long time, if you drink water, arsenic contaminated water, after maybe few years, you will see this type of thing is happening, and ultimately it is happening, and people will die. Okay. And in we all know that in India, many places, even Chhattisgarh, here in West Bengal, in Bangladesh, everywhere this arsenic pollution is there, and lot of millions of people are getting affected for this. So initially in 1990s, it was still it is a hot topic, but that time, you know, any paper, anything you do related to arsenic, it will be published immediately. So we have done some methods, and it obviously it got published. Now, if you see the arsenic, in the position of arsenic in the periodic table, you see it is this group element, okay, nitrogen group element. So many properties of arsenic are very similar to phosphorus. Okay, phosphorus, and you know, phosphorus is an element which is there in our biological system. So that is why arsenic sometimes, you know, are replacing phosphorus in many biological systems. And it is a metalloid. Of course, it is not a, many books I have seen that arsenic is a metal, but don't say arsenic is a metal. It is not a metal, it is a metalloid. Metalloid means it is some property it is having like metal, some property it is having like non-metal. That is why it is called metalloid. And from the, you know, as you go up, it is non-metallic property. As you go down, it is metallic property. So it is in between, somewhere in between. So it is having, this is non-metal, this is non-metal, this is metal, this is metal, this is perfect metal. So here it is in between, so it is a metalloid. Anyway, so here oxidation state of arsenic, right? Arsenic, it is a nitrogen group element, so it is very similar. Okay. As nitrogen, you know, you can see nitrogen, you see for nitrogen ammonia is there, NH3. Here also arsine gas, ASH3 is there. Okay. Nitrogen zero state, that is molecular nitrogen or nitrogen gas. So here also arsenic. It is not a gas, but it is zero state, means free state. Okay, it is also there. Now arsenate, arsenic 5, arsenic 5 like nitrogen 5, nitrate, that is also there. So arsenate also there. Arsenite, nitrite, so here also three state, oxidation state, 5. So it is very similar. And organoarsenic, like protein molecule. In protein, nitrogen is in organic forms, organic nitrogen. Similarly, arsenic is there attached to it, carbon, so it is organoarsenic. This is much less toxic. You know, it is very opposite to mercury. Mercury, when it is attached to carbon, it is organomercury, methyl mercury, dimethyl mercury, they are very extremely toxic, even much more toxic than mercury zero. But here organoarsenic is much less toxic compared to arsenic 3 and 5. And among these, arsenic 3 is more toxic than arsenic 5. But arsine gas, this is a gas, it is very toxic gas. It has no color, it has no smell, nothing is there, but it is extremely toxic gas. Now I will tell you that gadget method, about the gadget method. Those who knows, for them, maybe you will easily understand. But those who has not seen this or has not done this, use this method, for them I will tell little bit. But before that, you can see here that how the why the arsenic is affecting our health, our body, or our biological system. That is, here you can see mercury, that these are thiol group, sh group. Many enzymes, they have thiol group. So when mercury is present, mercury goes inside our body, then mercury can form chelate or chelate with these groups. So you can see here, so enzyme activity will be lost. Enzymes are very active in our body, they are performing many works in our body, but once the activity is lost, means our system is affected. Similarly, arsenic here also can form the this type of complex. So arsenic also can destroy the enzyme activity. Similarly, as I told you that it is very similar to phosphorus. When it there is the some system, you know, that ATP, all those things. So once it goes here, the arsenic goes here, it cannot, our body cannot recognize, because they have similar properties, phosphorus and arsenic. So it may replace the phosphorus. Okay, in that case, it will create lot of problem. So because they are very similar, that is why it will be replaced. These are very detailed things. I will not tell you all those things because it will take much time. Now this is the, you can see here, this is the gadget method. What is the gadget method? Here you can take the arsenic contaminated water. It may be arsenic 3 or arsenic 5, anything. And first it should treat, the solution should be treated in two steps. In the first step, the arsenic 5 will be reduced to arsenic 3, and in the second step, the arsenic 3 will be reduced to arsine gas. So finally arsine gas is produced and it will be chased. It will go here. There is a something, it is called absorber, or you can call it trap or whatever. So here the glass wool is kept, glass wool soaked with lead acetate. Soaked with lead acetate. So here some glass wool is there soaked with lead acetate, but arsine gas is passing through it, and then finally it will go here and it will come to some solution where some reagent is kept. Forget about this, some reagent is there. In gadget method I am telling, some reagent is there which is SDDC, silver diethyl dithiocarbamate, and the solvent it is used either pyridine or chloroform. There is something else also, but I am not telling that. But solvent I am telling, it is some chloroform solvent or pyridine solvent. Both are extremely toxic. You know, chloroform, it is a trihalomethane, and you know that in drinking water system, chloroform is produced. It is carcinogenic. So here we are using chloroform in a bulk quantity to develop some color with the reagent SDDC. So basically, the arsine gas will come here, it will react with SDDC in chloroform solvent or pyridine solvent, and then it will develop some color. Arsine gas has no color. Final SDDC also very light color, yellow color, but it will finally form darker color, maybe red color, little bit red. And then we can easily determine the color, and depending on the arsine concentration, the color will be intensified. If it is more, it will be more intense. And finally, we can determine the arsenic, we can develop the arsenic calibration graph, and then we can determine the unknown concentration of this solution, means unknown sample. So this is the method. But because chloroform is very toxic, so we thought that can we replace chloroform by something, some green solvent. Green solvent means the solvent which is non-toxic. And water is the best solvent, because water is there in our body. So water is the best solvent, green and most green solvent. So what we thought that instead of the chloroform or pyridine, let us use water, and let us use some micelle. Let us use some micelle. So SDS, sodium dodecyl sulfate micelle, we have used here. Silver nitrate, because silver diethyl dithiocarbamate, so it is a silver salt. So we also have used silver salt, silver nitrate, but it is much cheaper than the SDDC reagent. Okay, and other part is same. So we have seen that here also some yellow color is developed. We can prepare nice calibration graph, okay, of arsenic, and then we can determine the arsenic concentration in a much better way with more sensitivity and more reproducibility. But we don't have to use chloroform or pyridine. Okay, so that is our method. That is why we call that modified gadget method. It is called modified gadget method. And what is happening here, actually nano silver is being formed here. Why nano silver? Because arsine gas is a reducing agent. Arsine gas is a reducing agent. You are using silver salt, means silver plus. So silver plus is reduced to silver 0. Okay, so that is the method. And because SDS is there, it is an anionic surfactant, so it is stabilizing the silver sol or silver 0 and forming some color, stable color. Okay, so this is a very simple method. One of my PhD student, he used this method in his entire PhD thesis. We have published also, and many other students are also using this method. So basically this is the mechanism. SDS micelle is there, where it is the sodium dodecyl sulfate, so it is anionic surfactant, so this is the anion. Silver plus, so silver plus initially is attaching here, silver plus, and this is minus, so it is a ionic interaction. And then arsine gas is coming from this, coming through the tube I have shown you, and then finally it is getting stabilized, silver 0 nanoparticles, silver 0 nanoparticles. And then you can see that here it is the, initially this is the blank, this is the blank, there is no peak here, and finally this peak is coming for silver 0 nanoparticle. It is at around 400 nanometers. These are the nanoparticles, you can see very well stabilized nanoparticles, well separated. Okay, and then this is the size distribution, because all will not never have same size, you will have some distribution. So this is the distribution, but they are not very far. You see that the minimum size is around 4, and then maximum is 16, so it is not very wide, but it is good nanoparticles. Now there is another method I will tell you here. As the concentration of arsenic is increasing, then peak height is increasing, means absorbance value is increasing. Okay, more and more arsenic means more and more intense color, more and more peak height, that means absorbance value. So you can have very good calibration curve very common means general calibration curve with the positive slope. But there is another method I will show you. It is opposite. Opposite means it is a bleaching. It will bleach. Bleaching means the method is like this. Here I can show you. Here you can see this is also some micelle. Okay, some anionic micelle. Okay, anionic micelle. This is the structure, and this is the negative ions. So if you put some cationic dye like methylene blue, then it will be attached here with the head group. And once it is attached to the head group, then if you pass the arsine gas, then what will happen? It will react with the methylene blue, and it will bleach the methylene blue color. It will bleach the methylene blue color. Methylene blue is dark blue color, so it will be bleached. So you can see here that arsine gas is coming, it is bleaching the color, so color is bleached. And in presence of nanoparticles, it is more fast. The bleaching is fast, but if you do not put nanoparticles, then also it will happen. Okay, and here you can see that why it is happening, because arsine is a gas, but it can penetrate inside the micelle. Okay, it can penetrate inside the micelle. How do you know? You can see the size. The SDS micelle size is less, means it is smaller micelle, but here you can see the size has become bigger, 13 times bigger. Okay, why? Because nanoparticles have gone inside, so the size has become bigger. Now this is the nanoparticle. This is the adduct with methylene blue. Now nanoparticle, that arsine gas is coming, it will go inside like this, and then it will bleach the methylene blue. So as the arsenic concentration is more bleaching. More concentration means more bleaching. It is just opposite. Okay, like you have done maybe fluoride. If you have done fluoride determination with the standard method, you have seen that fluoride, when the fluoride concentration is higher, it is color is going down. Okay, so it is very similar to that. And the arsine gas is produced here by borohydride, not by this type of gadget method. We have used some other reducing agent, but here it is sodium borohydride being used to produce the arsine gas, okay, from the arsenic contaminated water. And then this type of bleaching is occurring. Okay, so it is another method. Okay, but here also you see the application. The surfactant application is there. It is called micellar catalysis. So micelle is helping in the catalysis. So it is called micellar catalysis. Micellar reduction. Micellar medium it is going on. So it is micelle is influencing the reaction. Okay, this is another method. Now I will tell you something. So these are all in the analytical method how we can apply micelle. Okay. Now I will tell you civil engineering. Okay. Now I am coming to removal and all those things. So how we can apply micelle for removing something. Okay, that I will tell you now. This is a common thing. Many of you are working on dyes, right? Dyes means dye contaminated water. Lot of people are throwing dye contaminated water in the ponds, in streams, in rivers, every in canals. Okay, and now some dyes are coming in, even in the groundwater. So this is very bad, and most of them are very toxic. Okay, and they have long means they are having longer lifetime also. So what will happen then? Means if those dyes we drink dye contaminated water, what will happen? It is our task, it is our challenge to remove the dyes from water. Okay, and also make people aware that okay, you before throwing it in the natural systems, please remove the contaminant, remove the dye from the water, then only you can release the water into the water bodies. That we have to make. So both things, awareness is also required, and also the industries or whoever is using dyes, they should take care of it properly. Now what are dyes? If you look into the dye structures, you will see that there are some groups. functional groups. They are called chromophores or chromophoric groups. Chromophores. So this is one chromophoric group. This is called azo group. Okay, azo, N double bond N, azo group. So they are responsible for the color. These types of groups are responsible for colors. That is why they are called chromophores or chromophoric groups. And there are some oxochrome. Oxochrome means they increase the color, they intensify. Okay, there are some groups. So here I am showing only the chromophoric groups. So this azo group is a chromophore. Now, this is the azo dyes are most common and they are most toxic. 90% of the dyes are azo dyes. Say, for example, methyl red, this is methyl red, procyon red, this is procyon red. Both are having the azo group, right? Another group I will show you, this is also common. This is called triphenyl. Three phenyl groups are there, so it is called triphenyl. And here it is the actually methane group. Methane means CH4. So CH4, three hydrogens. Actually, there is no hydrogen here, you can see, but carbon is there. So basically, three phenyl groups. Here one double one. So that is why it is the name is that triphenyl methane. So one example is malachite green. The other example is crystal violet. They are all triphenyl methane dyes. They are used, malachite green is used for various purposes as antiseptic, aquaculture, fisheries, food coloring agents, dyeing cotton, wool, leather, all those things. So these are very common. Okay. Maybe you have seen that they are being used in fisheries. Maybe you have seen that sometimes in the skin of the fish, it is having some colors, green color, bluish color. So maybe they are also absorbing the dyes. And when we eat the fish, we are unknowingly we are eating the dyes also. So these are very dangerous, na? Carcinogenic. Many dyes are carcinogenic. And another thing we have to remember, especially those who are working with dyes, sometimes we work for decolorization. So, for example, we are using some method when we see that it is decolorizing the dye solution. But decolorization does not mean that the dye is going out. Basically, dye is maybe, but dye is converted to another form. Like this one, when this double bond is broken and some hydroxyl group is entered here, this is totally means it does not have any color, colorless form. This is colored form, this is colorless form. So it does not mean when the color is gone, it does not mean that the molecule has gone or degraded. Same thing is happening for phenolphthalein. You have used phenolphthalein for acid base titration. In acid, you know that it is colorless, and in alkali, it is pink. So, when you change the pH, it is going from one color to another color. That means it is not breaking down, it is just going from one form to another form. So, degradation means you have to break down the molecule. You have to break down the molecule and you have to oxidize the molecule in such an extent that finally it goes to some mineral form. Mineral form is inorganic form. So what is happening? Mineral form means nitrogen will go to nitrate, nitrite, carbon will go to means carbon dioxide or carbonate. Phosphorus, if it is there, it will go to phosphate. This is called mineralization. So organic molecule coming to inorganic form means mineralization. That up to that point you have to go. Then actually it is degrading. It is degradation. Otherwise it can form another molecule that may be more toxic, or it may be going to one form to another form. It may be more toxic. So that is not actually our job. Our job is to either you can have to remove it totally through adsorption or something, or otherwise you have to degrade it. You have to degrade it. Okay, that is called mineralization. Now, our goal is both adsorption or removal through adsorption or degradation. So today I will tell you not the degradation, but I will tell you only adsorption part. Okay, how we can do that. Today, today it is a real challenge. You have heard that zero waste management, zero liquid discharge. Um, all those terms are coming now. Sustainable development. Okay? For environmental engineers, these are very common terms now. Okay, so zero waste management means we will not throw any waste. We will manage in such a way that all the waste now we will recover and then we will reuse. That is the 3R principle, or now 4R principle has come. Okay, so these should be the goal for every person. Otherwise, we are contaminating the water. One day it will be like this, we do not have any drinking water. After 50 years, if it is continued like this, then we will not have any drinking water. So that is the situation that is going to come. That is why these are all very hot topics now to do. Okay, for the engineers or scientists, whoever. Now, this is the prevention of pollution, green chemistry. So green chemistry also is very important now. What is green chemistry? Green means which is non-toxic, like green solvent. Okay, green method, green design, everything green. Okay, so green chemistry means there are 12 principles here. Prevent waste, design safer chemicals, products, all those things. Use renewable feedstock, use catalyst, use safer solvents that you have just now we have seen. Use catalyst. Okay, then energy efficient, it will be energy efficient, it will be quicker. You can do some reaction at lower temperature if you use the catalyst, so it is energy efficient. Now design chemicals and products to degrade after use. So whatever you will use today, it should be naturally degraded. In natural products, if you use, it will be naturally degraded. Okay, like petroleum products, now it is being discarded. Don't use petroleum products. You have to save petroleum, sustainable development, okay, sustainable growth. So in that respect also I must mention that all detergents are produced from petroleum product. They are petroleum product. And soaps are coming from oil, vegetable oil, cooking oil, okay, or animal fat. They are coming, this is the starting material. That is why cooking oil is biodegradable, but detergent is not biodegradable. Most of the detergents are not biodegradable. That is why it is more hazardous. Detergents are more hazardous compared to the soaps. Soaps are biodegradable, less toxic. Okay, so today these all those things you have to consider to have good means safe life. Okay, now here I will show you how mycel or micellar chemistry can help us in this regard. Prevent waste, first one. Why I made these colors? Because some of the topics will be addressed here. That is why. One topic I already addressed, use safer solvents. But other things I will tell you in a very brief way. Okay. So let us see this one. This is solubilization and adsolubilization. Okay, solubilization I already told you. Benzene is insoluble in water, but if you put micelle, then it will go inside and it will be solubilized. But typically it is in water medium, water aqueous medium. Okay, so that is why it is homogeneous condition, homogeneous medium. It is solubilization. This one is also solubilization to clean the cloth, to make it free of oil. This is also solubilization. But if we want to use this phenomena, this chemistry in practical purpose, then we have to attach the surfactant in solid surface. Why? Because here you can see that if you think about this molecule is a contaminant, then it is solubilized. but the whole thing is in water medium. If you want to throw it, water is also you have to throw, water also you have to throw. You are throwing the contaminant as well as the water, so you are not recovering water, you are not recovering the contaminant. That is not our goal. Our goal is to recover the water, that means decontaminate the water. Our goal is to recover the contaminant also. How we can do it? That is the ad solubilization is a very new topic, and it is known for a long time, but it was being used in chemistry, means theoretical thing, not in practical purpose. But from our lab, actually, possibly you know Professor Adak, Ashok Adak, with whom Dr. Bijoli Mondal has done the PhD. He is the first person to start his work with, means we are together. So in our laboratory, and then he applied this technology. It is a very new technology, ad solubilization, for practical purpose, in engineering purpose, to recover the dye, to recover phenol, to recover other things. Okay, and so how you can do it? Here is the mechanism. What is the mechanism? These are the contaminant, for example, and now this is a solid surface. This is a solid surface. Solid surface. Okay, now, this is the surfactant molecule. So, surfactant molecule, this is the first layer of surfactant molecule. So, this is attached, the head group is attached to the solid surface. So, the molecules are forming the layer. This is the single layer. But then another layer is coming. This is opposite way. So, these are the head groups, and if it is anionic surfactant, then it is anionic head group. Okay, if it is cationic surfactant, then cationic head group. But this is the portion where it is hydrophobic zone, just like this. This is the hydrophobic zone, hydrophobic core. CORE core means inside. Okay, here it is also same thing is here. Now these S molecules, where it will come? It will come here, because this is the hydrophobic, this is also hydrophobic, so it will come here. Now what is the difference between this one and this one? This is on a solid surface. So this solid surface, and it is in water. The whole thing is in water. Contaminant is in water. Solid is also in water. But solid is it made in such a way that some bilayer, means double layer of surfactant is formed onto it, onto the solid. Then this is the region, hydrophobic region, that is formed. So it will come here, these molecules will come here, and then it will be captured, it will be trapped, it will be trapped. So if we can take out the solid, then the whole thing will be taken out, means the solid is also taken out, contaminant is also taken out, water will be free of the solid as well as the contaminant. So we are getting back the water. Free means clean water. We are getting the clean water, we are getting the solid back with the contaminant. So this is the theory, okay? And it is called ad solubilization. Why it is ad solubilization? Because two things are happening. One is the adsorption, another is the solubilization. So it is on adsorbed, means adsorbent surface it is happening, okay? That is why ad solubilization, and this is just solubilization. I hope you have understood. Now the question from you will come. I know many of you are now thinking how the molecule of surfactant is being attached here. There is no adhesive, there is nothing else. So how it is attached? Yes, this is something which you will see now, that one important parameter is there for solid surface, that is called pH ZPC. pH ZPC. pH ZPC means ZPC means 0 point charge. pH means at what pH? The surface, solid surface will have no charge, that is called pH ZPC of that particular solid. Okay, so it is characteristic. For alumina, our work I will describe here, the alumina work. So alumina, normal alumina, okay, normal alumina. So alumina has the pH ZPC, this one 9.15. That means what? At pH 9.15, alumina is having zero charge. But if you go below this pH, means say 4, 5, something like that, it will be positively charged. If we go beyond that pH, say 11, 10, then it will have negatively charged. So we have attached the anionic surfactant. So head group is anionic, right? Head group is anionic. So head group is anionic. So if we can make the charge of the solid positive, then positive negative interaction will be there. So it will be attached. So in this particular case, I will tell the alumina, we made it positive charged. How? Certain pH we have maintained, so it has become positive charge. Then we have added enough anionic surfactant, sodium dodecyl sulfate, SDS. So it has the anionic head group. So it will form initially a monolayer. Then with the increase of concentration of surfactant, it will form a bilayer. And so this type of structure will be formed on alumina surface. Then it can capture this thing. So if it is a hydrophobic molecule, it can come here. If it is the opposite charge molecules, which is the opposite charge of this head group, then it may come here also. Okay. So we have used some dye recovery. So dye, most of the dyes are charged. Like just now I have shown you. Just now I have shown you the structure. If you go back to the structure, this one, then this is methyl red. So methyl red, here there are functional groups. So functional groups may be anionic or cationic groups may be there. So if it is anionic group, then it is negative dye. If it is cationic group, then it is cationic dye, something like that. So COH group is there. You know that COH can be CO minus. So in that case, it will be anionic dye. Okay, and here this is the you see this group is cationic group. So it is a cationic dye. So dyes are cationic or anionic, mostly cationic or anionic, and they have color, they have fluorescence also. Okay? So they have some properties. So depending on which dye you want to remove, you have to choose the solid, and you have to know what charge it should be formed on its surface. So that is your part. Means you can design the material. Okay, that is the civil engineering or chemistry people's job. But in our case, the thing what I am explaining here, so there it is anionic surfactant and alumina. Solid is alumina and the surfactant is anionic surfactant. Okay. So when you can ask when the monolayer will be formed and when the bilayer will be formed, how should we know that okay, monolayer has formed or the bilayer has formed? When the monolayer is formed, it is called hemimicelle. You know hemi means half, hemisphere, hemiacetal. There are many you know many words with hemi. So hemi means half. So hemimicelle means only one layer. Micelle is not there, only one layer of surfactant, that is hemimicelle. When the double layer is formed or bilayer is formed, it is micelle. Okay, but here it is not. Here it is another term, admicelle, adsorbed micelle. So admicelle. Okay. Now let us see now a few slides I will show. I will not go into details because then it will be means you will feel bored. So I will just show you the principle behind it. Okay, the principle and some few slides, the things what is happening here. You can see it is an isotherm. Those who are doing adsorption studies, they must have done some isotherm studies. Isotherm. So basically, this is the isotherm of a surfactant molecule on some solid, means solid and water. Of course, the solvent is water. So isotherm means the distribution of the molecule, particular molecule in two phases. So one is the alumina, say for example, in this case alumina, and one is the water. Okay, two phases, and the molecule is anionic surfactant. So what we will see, isotherm we see very smooth like this, but here if you do it very nicely, then you will see that there are several slopes coming. Several slopes. Here one slope, another slope. Each slope is telling about something. Okay, this slope is telling that the things are just started and it is getting absorbed. Second region will tell you, okay, it is more absorbed. Then here you'll see that almost bilayer is formed, and then here bilayer is formed. Now it is saturated. Now if you add more surfactant, then it will not add anymore. It will remain in the solution phase, and some more micelle will be formed. Anyway, it will not come here on the solid surface. So this type of isotherm you will get, and from the region you can tell what is happening there. Okay, now obviously our aim is to come here, means we want this type of structure on the alumina surface. Now let us see what is the application. Here you will see that this is the dye. This is malachite green. I have already shown you that malachite green is a cationic dye. Okay, now cationic dye and anionic surfactant, so it is opposite charge. Now what is happening, you see alumina, this is the dye solution, very dark color, malachite green blue color, it is very dark color. Now if you put alumina, you see nothing has come there, it is not absorbed, almost no absorption. Okay, but if you put SMA means surfactant modified alumina. Surfactant modified alumina means that alumina on which you have produced the surfactant bilayer. So here if you put, then immediately you will see that all the dyes have come in the solid surface. All the means solid surface has become blue, the water has become colorless. This is colorless. Why? But here you may tell that, okay, little bit blue I can see. No, this is the reflection. This is not color. This is actually reflection. And here you can see that 97% of the dye has gone to SMA, but only 13% has gone to alumina. And it is a very fast process. You know that means those who are doing absorption studies, you all know that how important it is, the absorption, for absorption to become fast. We need fast absorption. If it is very slow, if it takes 14 days, 2 days, 5 days, 3 days, 4 days to get absorbed, then it is of no use. Especially the continuous mode of operation, if it takes more time, it is of no use. It should be quickly it should be grabbed. You cannot imagine that SMA can grab the dye molecule even in 30 seconds. Most of the dyes will be captured in 1 minute. Okay, although here it is said maybe more time is given, but it is from my practical experience I can tell you that 1 minute is sufficient to grab the dye. So you can imagine how fast it is. And also it is settled. It is settled means separation problem is much easier. You can take out the water from the top, and the dye you can recover also. How? If you put some alcohol after recovering the water and separating the solid, if you put some alcohol or acetone, immediately dye will come out, and you will get back the solid. Okay, free of dye. Then you can use again the solid to recover again the dye. So you can see here that it is a continuous process. You can make, you can design. Dye you can recover, water you can recover, solid you can recover, and then the solvent also, that solvent means the alcohol or acetone, you can distill out. So solvent you can also recover. After certain cycles, when you see that efficiency of the surfactant modified alumina has come down, then you can again modify the alumina with the surfactant. The first step, modification of alumina with surfactant, that you can go back there. So you don't have to throw anything. So it is a green approach. You have seen that prevent waste is the first point of green chemistry approach. So it is, you can make it a green chemistry approach. Here, continuous mode, you can see that it is a dark colored dye contaminated water. You are passing to the adsorbent, that is SMA. and it is going upward mode, upflow mode, it is coming out. You see that this is totally free of dye, and you see here that color is captured here. So you can use it for a very efficiently for continuous mode of operation also, fixed bed column. Okay, initially this is the batch mode of operation, and this is the continuous mode of operation. Okay, you see here in a bucket the dye contaminated water is there, so it is passed through this, and then you are getting back the dye free water. This is one method, very good method actually, we feel. And now we can see the many worldwide this method is being used. They're using different adsorbent, that but basic principle is same. Maybe they are using another dye, maybe they are using another contaminant, maybe they are using another solid material or another surfactant, but basic principle is the same. Okay, so this is the adsolubilization principle. Now I will show you another thing, that is with the the renewable. I have shown you that green chemistry approach, that renewable materials, not like petroleum. We cannot use, means we have to minimize the use of petroleum, but we can use the agriculture based products. We can use marine based waste. Okay, so that one I can show you. Okay, here you see this is some lobster or maybe crab or whatever. So they have some exoskeleton, that is some skeleton, hard skeleton there. So in that skeleton we have some compound, we can isolate it. This is nothing but chitin or ketene. Okay, ketene. And from ketene we can have chitosan or chitosan or chitosan, whatever. Okay, so deacetylated product of chitin is chitosan, means controlled deacetylation. 50% deacetylated product is chitosan. So I will show you the, so you can have enough of this material. This is waste material, marine waste. So you can collect it, you can isolate it, then you can use it. Okay, how you can use it? There are many other sources also. You can see sources of chitin, chitosan. This is so many squid, crab, prawn. These are all these other things, conch. This other things are also there. Mushrooms also. Okay, molars. So from all those species, you can have this chitin chitosan. Now you can see here that annual production of chitin from marine waste is 10 to the power 12 to 10 to the 14 tons. So you can imagine how much waste is being produced every day globally. Okay, even if you go to that Kerala side, you will see that they are dumping this waste. Okay, now main thing is that you can make out of it chitosan, you can make different kinds of things like flakes, powder, fiber, then nanofiber, then nanoparticle, gel beads, all those things. So you can use whatever you like, but you can prepare it. How you can prepare it? We have prepared the gel beads, so I will show you the method for gel bead preparation. So here it is the chitosan solution taken dissolved in acetic acid, and it is a coagulating mixture. Coagulating mixture means when the drop will come here, it will form the bead structure, it will form. So this is a mixture. What is this? Water, methanol and NaOH. So in this mixture, when the chitosan solution is dropped, it will form the bead. This is a very simple method. Okay, now so we have formed the beads. Okay, we have formed the beads. Why I have gone here, you know that for alumina you have seen that you have to make the means pH below the pH ZPC. That is why we made during the preparation of this bilayer anchored alumina, we have used the pH 4.5. 4.5 is well below the pH ZPC of alumina, so it formed the positive charge. But here, in case of chitosan, the structure is like this. You can see here that chitosan, if you look into the structure, it is natural material. So you can see here this NH2 group is there. So NH2, you know that from organic chemistry, we know NH2 can be protonated, NH3 plus you can make easily. So depending on the pH, it can be made NH3 plus. So you can make it positive charge, right? Can make it positive charge. It is a natural material, but you can make it positive charge. So when the positive charge is there, what will happen if you treat it with SDS? Same thing as we did with alumina. Here it is chitosan gel bit. Okay, so how it is happening? How is the isotherm nature, that I will see. Okay, so here also you can see this type of isotherm. So there are different zones. Here one zone, here one zone, one zone, one zone, one zone. So isotherm, this is also isotherm. So in the isotherm of this chitosan and SDS, means on the solid surface chitosan hydrogel bit, and the in the not pollutant. I will not tell it pollutant here. I will tell you the compound, that SDS molecule, how it is distributing in two phases, water and the chitosan gel bit. So you can see here. So that means some places it is just started forming the monolayer, some places it is already formed the monolayer, bilayer. Okay, here it is a saturation. So and it is huge. The capacity is huge. Enormous capacity means enormous amount of surfactant can be absorbed by the chitosan. Okay, this is another part. This I will not discuss here, but chitosan gel bit can be used for surfactant removal also. Very well. Means it is, we have used it. Surfactant removal, SDS removal, we have done with chitosan bit. Huge, enormous capacity it is having. Okay. Here you can see the capacity here. You can see here how much. Now what is our goal? Our goal is to form the bilayer on the chitosan gel bit, and we will apply it for some purpose, some contaminant removal. So this is our actually the flow chart. So chitosan powder, then chitosan solution, then chitosan beads, and then we will modify it in with SDS with two different concentrations. One is well above the CMC, and it is close to CMC. So we have made it, means pre-CS, means pre means here it is pre-micelle, means micelle is not formed, and here it is post micelle, means it is bilayer formed. Here it is not bilayer, it is bilayer. So how is the property? That's what we wanted to see, whether bilayer formation influences the capturing the contaminant more, or it has no effect like this. So this is our aim. Okay, this is our goal. Now here you can see that this is the scheme, our scheme. So what is the scheme? Scheme of surface modification of chitosan bead and capturing of nickel 2. So in this case, not the dye, I will show, we have done dye also, but here I will show nickel. Nickel, you know, very toxic, and it is coming from many industries. Nickel 2 or nickel 2 plus, whatever you can call. So how nickel 2 plus can be captured by the surfactant modified chitosan gel bead. That is the scheme here. Okay. So chitosan gel bead. Now this is the post CS bead. Okay, we have used this very high concentration of SDS. So this is the bilayer form. This is the bilayer. Okay, so this is the monolayer, and this is again another layer. So bilayer. So this is post CS beads, and then nickel. So these beads, modified beads, are added into water which contains nickel 2 contaminant. That is the contaminant nickel 2 plus. Okay, so nickel, because it is anionic group, SDS means anionic micelle, so anionic surfactant, so this is anionic group, and nickel 2 plus is cationic group, so immediately it is captured. It is immediately captured by this gel bead. Okay, and if it is pre-CS bead, means modified with a lower concentration of SDS, then how it is happening, how it is showing, and when it is formed bilayer, then how it is, what is the property, that I will show you. Okay, you see here, this is the pre-CS, this is the CS, only chitosan bead, and this is the removal of nickel, and this is the adsorption capacity of nickel, means adsorption capacity of the bead or modified bead for nickel. Okay, you can see here, you can see here that when it is only chitosan, then you can see the removal is only 20%, around 20%. When is pre-CS bead, means monolayer is formed, then you can see 40%. And when it is post-CS beads, then you can see that it is much higher. Okay, so that means what? When it is bilayer form, then it is much more efficient, right? Then it is much more efficient to recover. Here I will tell about recovering, because it is green chemistry approach. So we can recover the nickel, we can recover the surfactant. Okay, we can recover the dye, and again we can dissolve the dye, dissolve the Ni2 or surfactant, so we can recover the contaminant. So that is why it is called green chemistry approach. This is the this is the condition. Okay, this is the condition here I have told. The concentration of nickel 50 milligram per liter. Dose, see the dose is also very less, 1.05 gram per liter, and then pH is 6.5. This is almost neutral pH. Okay, so this is the work here. Okay, this is the another thing, means not, we do not stop here. After recovering the nickel, what we will do? Should we throw it? What we will do? We can recover nickel, of course, but otherwise what we can do? You know, nickel is a very good catalyst. You know, Rani nickel. Rani nickel is a very good catalyst for means hydrogenation of oil. You have seen in industries. You can use many other applications are there for nickel zero catalyst. What we can do after this nickel capturing, nickel adsorption, we can form nickel zero by using a borohydride, that is a reducing agent. So nickel zero, and this nickel zero on the post CS bead is a very good catalyst. So it is basically utilization of waste material as catalyst. It has now become the waste after nickel recovery. Now it is a waste. We have to do it something, we have to reuse it for something, or we can throw it something. Then if we throw it, then again nickel will be contaminating the environment, so we do not want that. So we can use it as a very good catalyst, and it is also under the zero waste strategy, means we are not throwing anything, but we are using it again and again for some purpose. And waste to wealth, it is a waste, but we can making it, we're converting it to wealth. Wealth means catalyst, we can use it as a catalyst. So what is the catalyst that I will show you? It is very important, interesting reaction, that is the conversion of nitrophenol to aminophenol. What is nitrophenol? There is the phenol, so it is a nitro group here, para-nitrophenol. Okay, it is a very toxic compound coming from many industries. Okay, and it is under the priority pollutant now, emerging contaminant. Okay, but if you can convert it to here aminophenol, it is a very useful molecule, useful compound. Why? It is used for paracetamol production, it is used for many other purposes. Okay, so from a toxic compound you can prepare a important compound. It is obviously, it is a very good approach. How you can do it? By using some reducing agent. It is reduction, NO2 group is coming to NH2, so other part is remaining the same, so it is a reduction reaction. Okay, how you can reduce it? You can use sodium borohydride, or you can use other reagents also, like common reagent is iron and HCl. It is also nascent hydrogen is produced, and it is reduced, it can reduce the nitro group to amine group, but in that case lot of acid sludge will be produced. Again you have to manage the sludge, it is very difficult, isn't it? Sludge management nowadays is very difficult. So instead of that, if you just reduce it by borohydride, it is thermodynamically, it is possible, it is feasible, but it is a very slow process. Very slow, maybe 48 hours will be needed. Okay, but if you use a catalyst makes some reaction faster, right? If something is possible, you can make it faster. If it is slow, then you can make it faster by using a catalyst. We have seen that oxygen preparation, we have used MnO2 as a catalyst, right? Huh? In the school days, we have learned it that KClO3 to oxygen preparation, laboratory preparation of oxygen. We use some manganese dioxide as catalyst. So catalyst makes some reaction faster or energy efficient. So here also, if you just use the borohydride, reaction will be very slow. Long time it will take. But if you use some catalyst, it will be faster. So here again, I am telling that this is the nickel phosphate bead, which can be used as a catalyst for this reaction. Okay, and then it becomes very fast, very fast. Okay, so what is now we are getting that we are using things one after another without wasting the material or without throwing it to the environment. We are reusing it for some purpose, and we are converting some important molecule to converting some toxic molecule to some important molecule. Okay, precursor of paracetamol, you can understand. And it is for it has many other use also. I'm not telling those. So this is the theme today. Actually, the theme today for engineering or science, whatever, is don't waste anything. You use, reuse. Okay, reuse or recover, reuse. So this is the basic principle 12, that green approach, green chemistry approach, also 12 principles. So we have covered a few things only, but there are many things also we can do. So basically, application of, so let me go back to my top title. So it is basically the soap detergent and its use. Initially, I told about some analytical purpose, some method development, and then finally some engineering purpose, some environmental engineering means recovery of something, or catalyst, that is organic or inorganic or whatever chemistry you can tell. So these are the some of the applications, okay, of micelle or of surfactant. Okay, so these are some of the publications I have shown. There are many publications, but only a few important publications I have shown. If you want to know more, then you can go to the cross references also, or you can write mail to me, whatever you want you can do. Now finally, thanks or acknowledgement, I want to thank my students. Of course, they are the I only tell you have to do it, but they do it. So they are the main means worker. So there are Ashok and visually also did some work with me, but that is not myself. That is on phenol. She did some good work. She did absorption, but I could not put it because that is not dealing with myself. But Ashok did, or Sanjay Maji, he's in KIT. Then Shubhadeep recently finished the PhD. Sandeep, so they are all in good places. They are well established, and uh, some of my MTech students. She is completing almost. She will submit in this month only, Ankurita. And Deepshika is doing PhD in abroad. She is in some engineering jobs. He is also in engineering jobs. They did not do PhD, but they are both of them are girls, so they are doing PhD. And of course, Professor Pal, who is my inspiration. Thank you all. If you have any question, you can ask. I think we have some time.
Yeah, thank you, ma'am. Thank you for such an eye-opening and in-depth presentation. So truly, it has given us a detail about difference between soaps and detergent, which is very interesting to begin with, and a very uh, in detail discussion about how nanoparticles are being synthesized by the means of demonstration by means of gold. Especially the color change was very interesting for me, if I say so, to understand. Then we moved to this arsenic contamination. Ma'am, you have very well detailed about how it is interfering with the human and biological system, and how it can be uh, uh, the contamination can be removed in detail, especially the guts method you have discussed. Also, you have detailed upon this contamination of dyes. So, and the removal part of it. From there, what we also understand, we have been introduced to this new concept of absolubilization, to be specific, which is contributing to the larger goal of zero waste management, also contributing to the zero waste strategy and waste to wealth. So these are all something very interesting to know, especially that removal efficiency and the gel beads we are means you have introduced the preparation of gel beads from this biological waste. These are totally new topics and new arenas you have touched upon and enlightened us, ma'am. Thank you very much for this. And with that, I would like to open the session for the questions. So, from the comment sections, we have the few of the comments were like about the presentation, which was very detailed and very nice. Apart from the main questions which we got were like, what is the function of builders in laundry? And this is one of the questions we have received. If we can.
Yes, builders actually they are helping the actual surfactant to do better, to give more efficiency. Say for example, just simple example I can tell you. Say for example, it is hard water. Okay, so hard water, you know that there are some calcium, magnesium, ions. Okay, so if there is phosphate, you know that hardness removal we use phosphate, right? So phosphate can make calcium phosphate and it can remove the calcium. Uh, so this way they may use phosphate or they may use some silicate, some even some abrasing. You know, abrasing when we clean our cloth. Say for example, we rub it we rub it mechanical rubbing we do, right? So there may be some silicate type of thing they can make those efficiency of this detergent. Actually, I should not say surfactant, but detergent, they make it more, efficient. That is why it is called building something. They are not doing the actual work, but it is helping. That is why.
Thank you. I hope the participant has got the insight. The next question is, ma'am, which is very dangerous and why between arsenic 5 and arsenic 3, which is very dangerous and why?
That some of the things I have shown you now, arsenic, how it is doing in our after going into our body, how it is actually influencing. Okay, so only two slides I have shown that they can make the active sites inactive. Active sites of the enzymes they can make inactive, or they may enter into some important biological systems. They can replace the phosphorus. Arsenic can replace the phosphorus because they are very similar type, similar same group elements, so they have similar properties. So those things they are doing and hampering our, system, biological system. Arsenic 3 actually more dangerous, much more dangerous than arsenic 3.
Okay, ma'am. The another question which we are taking, last one for the session, is how to determine pH ZPC for any adsorbent.
Yes, this is very common question. Means common means important question. It is very easy. Actually, all my students are doing. You have to make several solutions. means water. You take water and then you vary the pH of this each beaker. The pH you should vary. Okay, so for example, the first beaker you make the pH 2, then 3, then 4, 5, like this, a wide range of pH you have to maintain. Okay, after that you put the solid of which you want to know the pH ZPC. Okay, and then you have to keep it for overnight. Then you check how is the change of pH happened. Means, say for example, you have made the first beaker you have maintained at say pH 4. Now after keeping for 24 hours with that particular solid, you see that pH has changed to maybe changed to 5 or 6. So pH, final pH minus initial pH, you have to calculate, and then it has to be plotted against the pH initial. Then you will get some this type of card. Okay, and it will, the cutting point you will tell you what is the pH HPC. It is very simple. Like, I means any paper you go here, you will get that one. One
Okay.
day, one day, only 24 hours experiment. 24 hours it will take. It is it means it is in the literature also. It is there in the literature. And how will you maintain it? You have to maintain the pH by using some acid or base, and you have to keep the some solid also. I think KCl or KCl you have to keep KCl. Okay, details I cannot tell you now, but this is the principle mainly.
Thank you, ma'am. Thank you. I hope all
Thank
the
you. Thank
questions has
you.
been addressed.
Yes, thank you so much, Professor Rajvanshi, and I must thank you all for giving me the opportunity to interact with you and to deliver some talk here. If you have any question, you can send me mail. My mail ID is there in the first
Ma'am,
slide.
if you can please share the slide with us, and our emeritus professor Dr. Somnath Ghosh has conveyed that about the usefulness and the enrichment you have provided through your presentation, ma'am. So thank you very much on
Thank
behalf
you,
of the whole
thank you, thank
department.
you so much.
ম্যাডাম থ্যাংক ইউ।
হ্যাঁ, তা আমি কি ডক্টর মন্ডল বলবো? মানে
না
নাম ধরে ডাকছি, কেউ কিছু মনে করছে না তো?
না না
কারণ ওখানে তোমার একটা খুব ভালো পজিশন আছে, আমি তোমাকে নাম ধরে ধরে ডাকছি।
না না ম্যাডাম কিচ্ছু না।
ঠিক আছে, ঠিক আছে।
ঠিক আছে ম্যাডাম।
যদি আন্ডারস্ট্যান্ডেবল হয় সেটাই আমার, মানে আমি সেটাতেই খুশি। মানে সেই জন্যই আমি খুব সহজ করে, সিম্পল ওয়ে আই হ্যাভ টোল্ড। ওকে, থ্যাংক ইউ,
থ্যাংক ইউ ম্যাম।
থ্যাংক ইউ। স্টপ শেয়ারিং।
ম্যাডাম চলে গেছে।
Hence, I thank all the participants for their presence today. Dear participants, please note that our today's afternoon session will start at 3 p.m. It will be a very interesting lecture on the topic of repair and rehabilitation of structures by Dr. Partha Ghosh, sir. Please rejoin the afternoon session 5 minutes before the scheduled time. Thank you, and thank you, ma'am, for your wonderful presence.
Thank you. I have not gone. Actually, I thought that I
Oh,
will
acha, question answer.
here only.
No, ma'am, there is in the comment section we have attended the questions and forwarded to you, ma'am. And thank
Okay.
you for your wonderful response.
Okay. Thank you. Thank you so
This
much.
session was very informative, ma'am.
Acha, thank you. Thank you. Thank you. See you
Thank you,
again.
ma'am.
Bye.
Yes, ma'am. Sure, ma'am.
Good afternoon, sir.
Good afternoon.
So you're muted.
Yes, good afternoon. Yes, it's audible. Is it audible?
Yes, sir.
Okay.
सुनने दे रहा? Hello, sir.
Yes, ma'am. Yes.
Yes. I can. We'll start. A very good afternoon, everyone. I, Deepti Elanki, Assistant Professor, Civil Engineering Department, Haldia Institute of Technology, welcome you all back for the afternoon session of second day online FDP on recent trends in civil engineering. The speaker of this session is Dr. Partho Ghosh. Dr. Partho Ghosh did his BE Civil Engineering in 2000. He did ME Structural Engineering in 2003 and PhD Structural Engineering in 2007 from Jadavpur University, Kolkata. He has joined as a lecturer of Construction Engineering Department of Jadavpur University in 2005. Presently, he is the professor of the same department. His field of research is concrete microstructure, bacterial concrete, geopolymer concrete, and building materials with sustainability guided for PhD students, and four more are doing PhD under his guidance. He has already guided 25 master degree students in his department. He has also written 2 books and 1 patent in his university. He is providing consultancy services for many government, semi-government, and private organizations in India and abroad. We welcome you, sir. Over to you.
Thank you, all of you. So, shall I start my presentation?
Yes, sir.
Okay. Yes, is it visible? Is it visible?
Yes, sir.
Good afternoon, all of you. So, first of all, I'd like to thank my deepest gratitude to Haldia Institute of Technology and all the organizing member. So, those who are doing such kind of activity in presence of all the expert engineers from different organization and institution. So it is really a good platform, and I that the way that you are organizing such kind of seminar, so definitely we can exchange our knowledge to each other. So basically, I am professor of construction engineering department, Jadavpur University, and my main work is doing research work as well as the teaching of students. So apart from that, as an engineer, you know that we have a responsibility to do such kind of consultancy work because people are expecting much more thing from us, like you also. So that's why I am just sharing a few more slide with you, so that I am at present doing some research activity as well as some consultancy work at a different part of our country. So the main part is that my presentation, that is the repair and rehabilitation of existing damaged structure. So before going to that part, so we have to know that the why we need the repair and when we need the rehabilitation, okay, and when we need the retrofitting. So there are different things is there, different ways there. So as an engineer, it is our main responsibility that in which way you are looking in any structure. So your looking is very important. Your experience of eyes is also very important. And apart from that, there are some other parties there. So that is there are some traditional way of the technique, and apart from that there are some another way of methodology is there, that is the based on the experience. So so you know that the while we are going to the repair and retrofitting technique, so there are some few things there that you need to know. So first of all, that the period of construction, and because you know that when we are going to any kind of design of a structure, so definitely first of all we are considering the design life of a structure. So that is for steel structures, you know that the minimum 75 years. In case of RCC structure, so that is normally 40 to 50 years we are going to design. So in this way, so the how much old the construction is, so that you have to know at first. Okay, so this is your first thing. And apart from that, another is that the type of construction, whether that is in RCC structure or that is in load bearing structure, or is it in composite structure. So in this way you have to classify. Okay, and after that, the what kind of investigation is already done, or what kind of investigation you need to do, so that you have to make a plan with the help of some flowchart diagram. And if it is a residential building, so then you have to know the how much unit of residential unit is there, as because you know there are some importance factor is there. So based on the people, so the important factor will changes from 1 to 1.2. So for that purpose, you need to know definitely the purpose of the utilization of the structure, or that is known the importance of the structure. So that's why the number of resident unit as well as the type of that means the utilization of the structure, that you also have to know. And these are the preliminary idea you have to gather from the site. And this is the first thing, this is the salient feature. And second one is the visual observation. So visual observation is very very important, because that visual observation will differ from man to man, eyes to eyes, okay, expert to experts, engineer to engineers, okay, client to clients, okay, because the way people are watching this structure, so definitely that must be differ from others as a engineers. Okay, so this is the visual observation. So other than the visual observation, the third one is the in situ evaluation through the different kind of non-destructive tests, which are popularly or widely using for our structural health assessment. And you have to collect some sample, because there are many more thing is there, so that is not possible to do the assessment at the site. So that purpose you need to collect the sample from the site, and you have to do it different laboratory as per as your requirement. And the whatever the number 1 2 and 3, the whatever the data you captured and whatever your visual observation, and whatever the your previous any design or drawing of the document is there, so based on that way you have to make on conclusion. So these are the some preliminary things before going to any repair and retrofitting work. So these are the, you know, that I am not going to in detail of that in situ evaluation of concrete. So these are the traditionally normally we are using that the ultrasonic pulse velocity test, Smith hammer test, measurement of half cell potential. Because one thing is that one gives you the surface hardness of the concrete, and another thing is that is there any internal flaw or internal void or internal micro crack is there. So that you have to know with the help of ultrasonic pulse velocity test. And the Smith hammer test, basically that gives you the apparent surface hardness of the concrete. And half measurement of half cell, basically that gives you the indication that how much the risk of corrosion is there based on the percentage as per ASTM guideline. Okay, so this gives you the idea. And definitely, you know, the measurement cover, you have to know maintain the cover meter cover of a structure as per the IS guideline. So sometime when we are not maintaining that one, so that may impact the durability of a structure. So that's why measurement of cover meter is very vital for structural health assessment. Okay, and apart from that, you know, the in some concrete is there which is exposed, highly exposed. So when the concrete is surface exposed is there, So if there is any micro crack is there, so that may chances the leads of carbonation. Okay. So carbonation, that means when pH value goes down. Okay. Normally it goes down 9 to 8 to 7. So below 9. So that means carbonation of a concrete. So carbonation is not the good property of a concrete because it leads so many undesirable properties of a concrete. So basically the starts of carbonation is very easy because from the atmosphere, if there is any carbon dioxide is there, so oxygen is there, so that will carbon dioxide will penetrate on the surface crack, and that carbon dioxide will acting on the calcium hydroxide. So it forms the calcium carbonate, that is CaCO3. So basically, when calcium carbonate has formed, so that is basically in very hard in nature. So when calcium carbonate is formed, so that means pH value goes down. So once pH value goes down, so that means so it leads the corrosion of a reinforcement because pH value less. That means it may leads the corrosion of a reinforcement. Once the corrosion started, so that means the reinforcement volume goes increases. So up to 30 to 40% the reinforcement volume goes increases. So when reinforcement volume goes increases, so that means it creates the internal stress inside the concrete. So as a result, when it creates the internal stress on the concrete, so that means the steel creates the pressure on the concrete, and as a result, the crack goes from wider. Okay, so thinner to wider. So that means the carbonation is very harmful for concrete. Okay, so that means you have to know that whether that concrete is effect of carbonation or not. And as well as chloride is also very important parameter for durability and the durability aspect, because you know the in presence of chloride definitely it may be presence on the admixture, or it may be presence on the soil, or it may be presence on the water. So that chloride may leads the corrosion of a reinforcement. Okay, so you know the adverse effect of corrosion of a reinforcement that I already discussed with you. And apart from that, the another test is there, the in situ compressive strength of a concrete. So that means you have to cut some existing sample, concrete sample from the existing concrete, and there are code is there 1516, so 2018. So that gives you the guideline. There are some LYD ratio is there. So based on that way, the LYD ratio, that means length and depth of the diameter of the core. So if that is in LYD is 2, that means if diameter is 50 mm, so in that case, if length you have to cut it 100 mm. So that means if LYD is 2, so that means the factor, that is the depth correction factor, that is 1. So the normally we are preferring, that is LYD ratio is normally 1. So based on that we are getting the applying the force, and we are getting the compressive strength, and then we are comparing, that is the cylindrical compressive strength, then we are converting it as a compressive strength of a cube, equivalent cube strength of a concrete. So this gives you the concrete core cutting. Basically, that is partially destructive testing. So that gives you the idea though what are the exact compressive strength of concrete is there. So these are the some destructive and as well as non-destructive testings there. Apart from that, there is pile integrity test. So you know that the when the pile is constructed, so there are two most important is there. One is the uniformity is pile, another is the length of the pile. So sometimes that is it may be the negligence of ourselves, because during the piling when we are removing the soil, so in that case due to the property of soil, so that soil may be fill up if there is some, if we are not using some bentonite, so that means the diameter may reduce, because soil may comes out from the outside of the other portion of the soil. So that means the whatever the diameter, negligence of whatever the target length is there, we are not penetrating that much length of concrete. So that means, so that is the shortage of pile. So there are two parameter. One is necking, is the reducing diameter, and in very less case, that is in the bulging of a pile. So bulging, that means the diameter is goes increases. So that is necking, as well as the length of the pile. You can check it after casting of the pile. So that is one kind of test, that is the pile integrity test, So that is also very important. So sometime running short the requirement
Excuse me,
criteria.
sir.
So in that time you have to,
Excuse me, sir.
yes,
Sir, your slides are
yes.
not changing, sir. Your slides are not changing.
No, I am not moving. I am not moving.
Okay, okay,
Now it's
okay.
moving.
No, sir.
Not moving. Okay.
It's in first
Okay.
first slide only.
Yes. No. It's continue. Now it is written continue. Moving. It's moving.
No, sir. No, sir. It's there in first slide only. From the right from the beginning, from the time you started, first slide only, it is showing.
Moving. Not moving. But in my case, it's moving. Okay. So I am just removing from slide share. Okay.
Yeah.
Stop presenting, and then I'm coming once again. Okay. So I'm coming once again. Yes. Is it coming? Is it visible?
Not yet, sir.
Is it visible?
Yes, sir. It is visible.
Dipti,
It
is
is
it
visible.
visible?
Yes, sir. It is visible, but
So now
try
it
to change the slide, please.
I'm changing.
No,
It's
sir.
coming.
No, sir. No, sir. It's not changing here.
Not coming.
No, sir.
Not coming.
No, sir.
But in my Windows it shows that it's changing.
It is frozen in the first slide only, sir. It's not moving.
Okay, now is it on first slide? Second slide is
Yes.
coming.
No, no. Still in
Third
first.
one.
No, sir. No, sir. First slide only.
Sir, the screen is showing not the full screen of the slide. It's showing the shorter version of the slide when it's open in the app like that. It's not in the full screen also.
Hmm.
Okay. So now is it full screen?
No, sir.
Is
No,
it
sir.
full screen?
No, sir. It's still in the short form.
Line.
Okay. Let me retry it. Okay. Just a moment. Let me retry it. Because in my case, in my
Yes, sir. Yes, sir. Now it moved. Hello.
it's
Hello.
moving.
Yes, sir. Now it is third slide.
Now it is in third slide. Still in the third slide only.
Now is it on first slide?
Yes. Yes, sir.
Now second slide.
Yes, sir.
Second, second slide.
Yes, sir.
Third slide.
Yes, sir.
First slide is there.
Yes, sir.
Fourth. So now is it fourth?
No, sir.
Fourth is there.
No, sir.
Is it
No, sir.
fourth?
It's frozen in third slide, sir.
Problem is there. Okay. So now changing 1, 2, 3, 4. Changing.
No, sir. No, sir. It's frozen in the third slide. In situ evaluation of concrete deterioration.
Changing? Is it
Not yet.
changing?
Not yet, sir. We cannot see anything. Not even your presentation.
So what you are what
We
hotspot?
cannot we cannot see your presentation, sir, right now.
What is the problem? I don't know. Okay. Shall I share the entire screen? Shall I share the screen?
Yes, sir. Yes, sir. You can share the entire screen. I'm also talking to the technical person only. I don't know what is the problem.
So now is it coming?
Yes, sir.
First
Changing?
Yes, sir.
slide.
Am I
Yes, sir.
audible, sir?
Yes.
Yeah.
Yes, yes.
Am I audible, sir? Ma'am, am I audible?
Yes, sir. You
Yeah.
are
Sir,
audible.
uh, can you just present your entire screen? You have presented your entire screen, I think. Sir, are you
Yes,
getting my?
yes,
Yeah.
yes,
Now it's visible. Now you can just change your slides.
yes. Yes.
Page up, page down.
Changing? Page
No, sir.
down, yes.
Yeah. It's now working, sir.
Yes.
Yes, it's coming. Page number 4.
Right. Yeah.
It's coming.
Okay, sir.
Yes, sir.
Yeah.
It's changing.
4.
Thank you, sir.
It's coming.
Slide number 2. Slide number
Is it
5.
open?
Slide number 6.
Slide number. This is slide number 3.
No, sir. Slide number 4. Small lag will be there, I think. But now it's slide number 3. Now slide number 3 came, sir.
No, no, no. I think
Slide
there is
number
some
2.
problem is there because this is slide number 1. Then slide number 2.
Now slide number 1 has come. Now 2 has come. Small lag will be there, I think.
I think that problem is there. Yes, yes. I think there are some problems. I am watching slide number 2, but you are watching slide number 1. So that is the problem.
Sir, there is a little time
I
lag. The
think there are
moment
some
you are
technical
changing
issues
and the
with
moment we are seeing it. There is a slight time lag, sir.
But that
When
is
the
that is
moment
not the thing, no?
5 seconds time lag is there.
that's the internet issue, sir. Sir, that is just the internet issue, sir.
So you can continue, sir. Now I think.
Okay, someone watch slide number 2.
Yes, sir.
Slide number 2.
Yes, sir.
So this is the slide number 3.
Yes, sir.
So that I already discussed it. Okay. So that I already discussed it. And next one is the slide number 4. That is the chloride content test and concrete core cutting. And next one is the okay. So this is the slide number 5. Okay. So this is the very important test, that is the flat jet. So this is the test. So that test has developed under Italy. So with the help of this test, so we can able to know the how much pressure can resist a brick wall. So basically for load bearing structure we can assess with the help of such kind of testing. So this is known as flat jack test, and IS also gives some guideline, that is as per IS 13946 part 1 1994 regarding the flat jack testing. So normally in case of dam structure, so I have involved so many dam project at our country, so where we are doing such kind of flat jack testing. Okay, and this is the test, you know, that is the pendulum hammer test. So to assess the actually the mortar strength. Okay, so you know the in case of load bearing structure, so there are some mortar strength assessment is very important for us. So in that case you can assess the strength of a mortar, okay, with the help of this pendulum hammer test. So this is the normal test, so this is the Smith hammer test. Okay, and these are some project is going on. So this is the ultrasonic pulse velocity test, and these are the very important tests. So half cell potential test. So are you on slide number 8? You are watching slide number 8.
Yes, sir.
Yes, sir.
Okay, so this is the half cell potential test. So basically, so in that test, so that gives you basically the idea that how much exactly the intensity of corrosion is there. So if it is normally more than 50%, so in that case normally we are rejected that kind of or we have to add additionally reinforced on that particular portion. So that test is very popularly or widely used in our construction industry, and these are also a cover meter test that I already discussed with you. So that also gives you the idea that whatever the cover you are doing, so that is based basically as per guideline of IS or not. Okay, so these are the core that we are collecting from the site. That is the in situ compressive strength test. So that is basically one kind of partial destructive testing. So that we are collecting from slab. And normally in case of column, so normally we are not recommended to collect such kind of core. So because it may damage the vertical reinforcement of the column. So that's why in very rare case we are recommended such kind of core cutting test. Okay. So this is the picture. So this is the picture. So that we are conducting the flat jack test. So basically, so this is the instrument where we are inserting some pressure. So basically, the flat jack test we are cutting some slot in here, and normally 2 mm, 3 mm thickness one plate we are inserting. There are some standard diameter, and the L and B width ratio is there. So based on that way, that plate we are inserting. So this is one plate, this is another plate we are inserting. Okay, and that both the plate having with some pressure. Okay, that we are inserting some pressure with the help of this instrument. Okay, so when we are inserting this pressure with the instrument, so up to certain limit, so there is no deflection. So after certain limit, so it goes some deflection. So as a result, so these are the deflectometer. So when this pressure is moves inside the brick wall, so in that case, so due to the expansion of the wall, so this extensometer will goes changes its length. So this is basically the strain gauge. Okay, so that we are inserting in here. So this is the LVDT, linear visual displacement unit. So we are putting it here, or apparently it looks that you need to cut some slot only. So on based on that slot, so how much the deflection is there. So basically you can check it, and apart from that, the stress versus strain. So basically we are inserting some stress, and from the this strain gauge. So this is the digital display board. So that is so this stress versus strain. So if you plot the graph, so then we can get also the E value of a brick wall. Okay, so this test basically we can check that how much load that wall can resist, and apart from that, how much the E value is there. Okay, so this is the flat jack test. So this is pendulum hammer test. So this is a very widely used instrument where we are checking the mortar strength, the mortar that we are using for brick masonry wall. Okay, and this is also the test, that is the GPR. So GPR basically in case of road construction or in case of the bridge deck, we are checking that where the any weak portion of a concrete is there. So basically that is one kind of ultrasonic test where the weaker concrete is there that gives you the velocity, lower velocity or lower peak value. So on that portion, so you can automatically you can spot or mark that portion where the low porosity of a high porosity of a concrete is there. So in this way you can check or is there any internal flaw or internal damage of a concrete is there. So with the help of GPR you can check it. Okay. So this is also input. So the previous is also very when the concrete volume is very high volume of concrete is there. Suppose any breeze deck or in case of any road rigid pavement is there, so you can check it. And apart from this, there is small particular portion. Okay, because this is a small device, so you can check any particular portion. Okay, so with the help of the impact echo test. So that is basically also the similar phenomenon of the ultrasonic pulse velocity test the ground penetration radar test. And this is also very advanced equipment, that is river locator, so that gives you the exact position of a river. And as well as there are some multiple layer of sometimes some reinforcement is there, so you can check it. So that instrument gives you basically a 3D layer of the reinforcement if there is any existence of any 2D or 3D layer of reinforcement is there. Okay. And this is also another good instrument, that is the concrete boroscope. So basically the concrete boroscope in case of like tunnel concrete, okay, or in case of some deep concrete is there, so you just insert this kind of one needle like of structure, and that needle like of structure having with some camera. Okay. And some camera, and while it goes inside the concrete, so is there any internal flaw or any internal defect or any internal damage is there, so that you can gives you the exact picture. Okay. And in which location, so that you can identify it. Okay. And another is that the permeability assessment, so that is also very very important, because inside permeability test there are some method is there in the laboratory, so we know that different method is there, but inside permeability, like any breeze structure, breeze PR, or any structure which is situated in the offshore structure which is in the sea, so that is known as offshore structure, so you can check it, so with the help of such kind of permeability testing. So these are the tests, like is initial surface absorption test, another is water permeability test, and next one is the clamp method and poroscopic method, oxygen permeability test, RCPT test, water pressure test, mercury porous intrusion test. So this permeability test is very very important in our civil engineering aspect on the basis of durability aspect of a concrete. So while you are checking the durability of a concrete, so in that case, if any concrete is less durable, so that means it has high permeable concrete. So high permeability permits the water through its interconnecting voids. So that concrete must be in rigid or it must be in less permeable. Or it must be impermeable. So that's why there are several methods there based on the location. These are concrete sample. So this is the water. So with the help of some pressure, so we are inserting some pressure. So how much water is penetrating inside the concrete? Okay. So there are some formulation is there, so you can check it that how much permeability, okay, of the concrete is there on the from the top of the concrete. So there is some permeability index is there, so you can check it that which one is the protective quality is very good or poor, so you can check it. So this is the one kind of permeability test, and this is the lab test. That means you need to make one concrete cube, or sometime we can make it as a cylindrical form, and we can place it on the this such kind of mold. And after that, on the top portion, this is the top portion of this instrument, then we are inserting some water pressure on the concrete, and there are some pressure will increases from day by day, and we are observing. And after 4 or 5 days, we are checking with the help of some scale that how much water is inserting on the concrete. Okay, so depending on the water absorption, so that will depends upon the how much density of a concrete is there. Okay, so these are the deemed standard penetration with their the less depth of penetration, that means it is more denser concrete. Okay. So that is our aim, is to make a concrete that means its water permeability is as low as possible. So this one is the portability test. So the process is simple. The instrument is only different. So one is a very large scale, another is a smaller instrument. So in this way, we are checking different way of the permeability of a concrete. Okay, and this one is the also the air permeability test. It's earlier case we are inserting some gas, and in this case we are inserting some air. Okay, so the inserting some air in the concrete. So this is the device. So this is the portion. So this one is the portion. So where the air will goes from this instrument to inside the concrete. So this is known as air permeability test. So we are inserting some air manually, and that air will goes inside the concrete, and depending on the permeability of concrete, it will goes inside the concrete. And this one is also some permeability test, that is known as oxygen permeability test. So this is the method is similar. So we are just inserting the oxygen in the concrete. So that means if more absorption of concrete, which indicates the high permeability of a concrete. So that's all. So there are some scale is there, OPI scale is there. So that is the standard acceptance limit. So that gives you the actual absorption of oxygen inside the concrete. And this one is very oldest technique, that is the RC rapid fluid penetration test. Basically, in this method, we are inserting in the high pressure and volume, we are inserting some current inside the concrete. So that means the charges, okay, some positive and negative ions. So we are inserting some chloride. So here some the sample, with the help of some cylindrical sample, we are some small portion we are taking, and that sample we are tightly rigidly fixed it, and that sample having with some chloride, and then we are inserting some current. Okay, so we'll check that how much current is passing inside the concrete. So these are the result RCPT as per ASTM guideline. So that means, so the more amount of coulombs passing, so that means fluid and permeability is more. Okay. So that means the less ion coulombs passing, so that means indication the less intensity or less chances of permeability. Okay. So suppose one pipe is there, so that pipe is water pipe is there, or there are some concrete pipe is there. So that means while we are going to design, or there are some defect is there while water is going inside the concrete. So you can check it that whatever the design water pressure is there, and but what are the design parameter, how much the design parameter was there, and exactly the how much water pressure is moving inside the concrete pipe. So you can check it. So this is the instrument, so you just touch it. So this is very sophisticated instrument, so high sensitive. So within a fraction of second, that gives you the how much volume or how much pressure is moving inside the concrete. Okay, so this is the depth of carbonation. Okay, so this is the depth of carbonation. So carbonation is also another important factor. uh, you know, I already discussed it. So for checking of carbonation checking, we are using the phenolphthalein solution. Basically, phenolphthalein is a solution, so liquid form. So it is in liquid form. So that is basically that gives you the pH indicator. Okay. So when we are placing it inside the concrete or top of the concrete, that its color is changing. Okay. So that means, the one is that is non-changed portion, and another is the unchanged portion, another is changed portion. Okay, that means it's pink color, that is non-carbonated, and basically the top portion there are chances, so which is highly exposed to the environment, so which may leads the carbonation of a concrete. So that means its pH indicates pH below the 9, and that is non-carbonated. Basically, normally the bottom portion of the concrete, which is there are this portion is concrete cover is there. So that means most of the case, so that is in non-carbonated concrete. So that means the top portion you need to protect the concrete, so that it there is a less chances of carbonation of a concrete. Okay, so you can check it. There are some instrument is there, so that gives you the very high rated carbonation of a concrete is there. So that is known as accelerated carbonation chamber. So if you place the concrete on some particular concrete sample, so within few days, so that will goes to carbonated. Okay. So that is also very small instrument. So we can check the chloride content of a concrete, because you know the chloride is very harmful for corrosion of a concrete. So for chloride checking, so you have to collect the concrete sample and you make it on the dust form. And very simple process. This needle you just inserting on the dust portion and you just switched on, and that gives you the indication that how much the chloride intensity over there. You know, the in the normal concrete we know that the intensity of chloride is 0.6 kg per meter cube, and you check it that what are the presence existing chloride content is present on the concrete or not. Okay, and this is also another test, that is the electrical resistivity test. So this is very good instrument, because that instrument will give you idea that the inside, suppose there are some concrete is there where the reinforcement is not exposed. Okay, so there are some minor crack is there, or there are some another portion the concrete is exposed, but the all portion concrete is not still is not exposed. So this is the very high sophisticated instrument. If you touch the without exposing the reinforcement, if you touch this instrument above the concrete, so that gives you the indication that whether that the inside the reinforcement is affected the corrosion or not. So that is the reciproc test. So these two tests, one is half cell test, another is reciproc test. Half cell test we are doing when the reinforcement is exposed, and when the reinforcement is not exposed totally cover, you cannot allow to expose the reinforcement. So in that case you use this reciproc. Okay, so that also indicate the risk of corrosion. Okay, so that is very good instrument. So these are the some guideline that based on this data that how much the result shows and what is your requirement criteria. So you can check it that inside there is any chances of corrosion or not. And this is also another technique, that is linear polarization resistance technique. That is also that is in case of some deck slab or in case of some heavy structure. So this is the method we are making some grid way, because very wide structure is there, so there is huge chances of reinforcement in different ways. So in that case we are making some grid pattern, and after that we are randomly checking throughout the structure. Okay, so that basically gives you the how much intensity of corrosion is there inside the corrosion inside the concrete. Okay, RCC concrete. So this is the simple instrument. So having it some sophisticated software. So when we are just placing this one, so no need to expose any concrete. Just we are touching this device on the top of the concrete, and then when we are running this one, then we can check that how much intensity of corrosion is there. So that is known as linear polarization resistance. And this is also another instrument. The thing is, the aim is same, but the instrument is different. Another instrument is their principle is same, but the collecting data, the use of instrument, user friendly, based on the user friendly, these are the different type of instrument. And this is most instrument in case of vertical structure. So where it is very impossible to make a grid, or sometimes it may be inaccessible, not accessible. So in that case, while you are scanning the structure, so you just scan it, so that it gives you the indication that how much the intensity of corrosion inside the concrete is there. So you just only need access some particular portion where you can thoroughly scan from top to bottom of the structure. Okay, so this is known as uh, galvanizic technique. Okay, so this one is also another good instrument. So suppose the very small instrument, you just move throughout the structure. So suppose this instrument, so this is the, you just look, this is the some, there are some intensity of corrosion is there. So that means when it intensity of corrosion is there, so that gives you the color indication. So that means that red color indication, that is highly corroded, and that means green color, that means less corroded, yellow color, that means it goes to corroded. Okay, so that color indication and up to how much depth the corrosion is affected, so that gives you the indication. Okay, so this is very good instrument, corrosion mapping. So if you scan the entire structure, so you will get the one map. So you can easily identify, and that gives you also the location through the graph chart, that how much depth from horizontally, how much depth from the bottom, and how much is from its origin, where you are selecting on origin. So that gives you the red color indicates the high, and then the moderate, and that one is the low. So this is also the intensity of corrosion measuring instrument. And this is also another type of instrument, that is the Windsor probe test. Basically this Windsor probe test also indication the how much hard of the concrete is there. So that is basically there are some needle. So when it is just like a drill machine, small drill machine that we are using as a carpenter people are using. Okay, so this is one kind of driller. Okay, so the very needle type of structure is there. So we are just trying to penetrate. Okay, so that means based on the softness, so the depth of penetration will depends the based on the softness of the concrete. So that means more amount of penetration, which indicates the weaker concrete. So that means suppose very 100 mm up to 100 mm the concrete is very soft, and beyond 100 mm that is hard. So you can check it that up to how much portion that is soft and up to how much beyond, so that is strong. So we can check it. Okay, so that is also very good instrument, because that also required very less amount of destruction of the concrete. So very less destructive test. Okay, and that is known as concrete pull out test. So that is known as lock and lock test. Okay, so this is basically, so you can check it the strength. Suppose when a building construction, you can check it. Okay, or suppose in case of any plaster, you can check, or in case of repairing mortar or any polymer modified mortar or any micro concrete that you are using. So that means you can check that how the bond stress is. So that means, so that is nothing but, so just only we are placing this instrument, we are placing this instrument, and when we are pulling, so first of all initially this instrument will goes down, and when we are moving this instrument, so it will try to goes upward. So that means this instrument indicates you that how much pulling force is required to pull the uh, that surface mortar or surface plaster or surface repairing thing. So how much pressure is required to pull. Okay, so that means known as the concrete pull out test. Okay, and this is also very very important capo test. Capo test means cut and pull out test. Cut and pull out test. So that means very small amount you need to cut. Okay, so at a time you can cut. Okay, and at a time you can pull it. So that means how much pulling force is required, and based on that pulling force, so that also at a time gives you the how much pressure. That means how much compressive strength it's required to pull the concrete. Okay, so that is very important test, because that is the substitute of core cutting test. So in the core cutting test, that is very difficult process, because you need to very big instrument, you have to set it, and then you have to collect the sample at the site, and then you sample it or prepare it with the help of some sulfur capping at our laboratory, and then you just placed it on the compressive testing machine. It's a lengthy process, but it's required, nothing is required on the field. You directly, you just pull, you can push it and you can pull it, and you can get the exact compressive strength of concrete. Okay, no need to do any kind of calculation. Okay, so that is very simple type of test. So that is the in situ compressive testing. So that is known as cut and pull out test. Okay, and that is also known as pull off test. So that is also pull out test and pull off test, both are same. So that is in small scale. Suppose any repairing product is there. Okay, so that is the repairing product, that is the carbon wrapping technique that we are using. So suppose many minor thickness of plaster that we are doing, so how much the strength is there, that the bond stress is there, so you can check it. So that is the just similar process of the pull out test. So that is known as the pull off testing. Okay, that's similar simple thing. So that is the in situ. So no need to do any kind of calculation. The instrument digital force that gives you the how much force is required. So by the way you can check it that how much the pressure is required. Okay, and this is also another instrument, that is the temperature monitoring throughout the throughout while you are placing the concrete, because you know that the normal time normal placing of the concrete time is normally 30 to 40 degrees centigrade. But in case of in some time, in some region in our country also, you know that the temperature is goes more than 50 degrees centigrade when we are placing the concrete. So in that case, so it may affect the hydration of a concrete also. Okay, so in that case, in case of very big project like a dam or like any important structure like a bridge or in case of any other important type of defense structure. So while we are placing the concrete, so that type of monitoring is very important. So just this is the instrument, so you can check it, you can place it, and that type of instrument just we are grip it with the help of the one is in the concrete and another is on the instrument. Okay, because the thermal expansion of steel and concrete is very wide difference is there. So in that case, in both the temperature you have to strictly follow. So that is known as temperature control instrument while you are placing the instrument. Okay. So another is that the while we are placing the concrete, so in that time or after just 1 day or 2 days the placing of concrete, there may be chances of some vibration may comes. Okay, so that vibration may come. Suppose the adjacent of the structure. So suppose any moving train is there, or there are some which the structure may touch with another structure. So that may be the source of any kind of vibration. Okay, so in that case you have to check it. So this is the sensor vibration sensor gas is there, so which is connected with some device. So you can check it that whether that concrete the crack comes out after 2 or 3 days or 1 day. So that is due to the vibration or due to the shrinkage. Okay, so that you have to check it. And this is also the in some type of some structure is there, so you need to maintain the level. So while we are placing the suppose any power plant, so I am also involved in different kind of power plant project. So where they are strictly maintaining the level, where the TG deck turbo generator drag we are placing, so there is very 99.99% accuracy must be there. Otherwise it is very difficult because we are leading the vibration of structure. Okay, so in that instrument basically gives you the whether there is any inclination is there or not. Okay, and this instrument basically that is very big type of instrument, but that instrument having many kind of facility. Okay, like ultrasonic, like Smith hammer, like surface hardness, like corrosion, like cover meter. So that is the one instrument, but having all the facility. Okay, so that is known as Beto scan. So that is very costly instrument. So while you would like to run the structure, the place of faults, it is quite impossible. But in case of road, concrete road, or in case of any bridge deck or any big type of structure, so that is that type of structure that within very less time that gives you the exact structural health assessment. Okay. And another instrument is there, that is the thermogravimetric analysis and differential thermal analysis. Because why this test is important, because in case of these are the two instruments, thermogravimetric analysis and differential thermal analysis. Because so the after fire assessment, the after fire, so how we can assess the structure. So we can assess the structure based on the how much weight loss is there on the concrete which is affected on the fire. So that means before and after fire. So after fire, so before fire, so what are the exact weight is there, and after fire, so how much weight loss is there. So you can check it with the help of percentage of weight loss with different temperature. Because in case of fire going on, so that means temperature is increasing gradually. Okay, so the rate of intensity is very important for us. So in each rate of intensity, so how much loss of mass is there, so you can check it. Okay, so that is known as thermogravimetric analysis. And there are different form is there, because the in normal concrete there are two more main product is there. One is calcium silicate hydride gel, another is sir that means 200 degree centigrade, 300 degree centigrade, up to 300 degree centigrade it can resist. So that is in brucite. Brucite is also a very harder product. But when it goes from 400 to 520 degree centigrade, so that is known as Portlandite. So Portlandite is very softer with comparing to the calcium silicate hydride gel. That is known as calcium silicate and nitrogen. That is it can resist up to 190.5. That means up to 200 degree centigrade. This is the formation. And when temperature is goes increases, Okay, so that means these are the formation. First of all is brucite, then portlander, then calcite, then ultimately that is the wallstone. Wallstone, that is one kind of ash. Okay, so that it has no strength contribution. So that means in after fire, while you'd like to do the exact status, so you can check that your concrete presently in which status. Okay, so this is very important test. So separately there are different kind of assessment is there. So different kind of formation is there, so you can check it, huh? Identify it, check it. So this is also similar thing. So one gives you the percentage weight loss, another gives you the formation, exact formation due to fire. Okay, so now these are the part that I already discussed, the assessment part. Because if you don't know the exact reason behind the distress, because as an engineer it is our main responsibility to know the reason of distress. If you know the reason of distress, then you can do the proper treatment. Okay, so that's why the diagnosis is very important as a civil engineer or as a structural engineer. After that you can go the treatment. Okay, so these are the treatment, these are the part, different kind of treatment is there. One is rehabilitation, next one is repair, third one is restoration, and then fourth one is retrofitting, and fifth one is strengthening. So these are the part. Okay, so these are the definition. So this is the rehabilitation. This is known as the process of repairing or modifying a structure to a desired useful condition. Okay, so that means it can be reused. So whatever the previous condition is there, so after earthquake, the whatever the present condition is there, so you have to go it the present condition, previous condition. So that is known as rehabilitation, so that it can use it. And repair, that means, so there are some minor thing you need to do. That means that is the corrective deteriorative. If any concrete is goes deteriorative or some minor damage is there, so you just replace that particular portion. You just place the some particular concrete, new concrete. So that is known as repair. Okay, so there are maybe different reasons, that is faulty design, faulty material, or improper shuttering also. That is initial repairing, the ultimate repairing. And third one is the restoration. So the restoration and rehabilitation is almost the same. There are few more little differences there. So that is known as the restoration. That means you have to go the original appearance. Okay. Suppose any historical structure is there. So in that case, you cannot do the repair, cannot do the rehabilitation. You have to do restoration in case of historical structure, because its original appearance once very important. So in that case, you have to follow the restoration. Okay, and retrofitting, that means suppose any structure is there, so you need to do the vertical extension. Okay, so you, that means you need to do the enlargement of the section. You need to do the additional reinforcement so that it can resist uh, due to the additional application or due to the additional load. Okay, so that means known as retrofitting. And so there are some minor damages there. So you take some the process or so that you can additionally structure. Okay, so that it can take the present load. Okay, so these are the symptom of distress. So what are the symptom of distress? First one is cracks. So that is very common for us. Second one is delamination. What is delamination? When some parts of the concrete comes out from the rest of the part. So that is known as delamination. And another is, third one is the staining. Stain is when concrete is changing its color. It is known as staining. And corrosion, corrosion. Steel yielding, as a result, steel yielding. Then is known as seepage. Seepage is the property where when concrete absorbs some water. So that is known as seepage. And spelling is also the part. Spelling is also when the plaster is separated from the concrete. So that is known as spelling. Okay. And the swelling, that means when concrete is gaining water. Okay. Concrete is gaining water. That is known as swelling. Okay. So these are the factors which influencing the repairing methodology. First one is the type and extent of damage. So that you have to know it, the type and extent of damage. So you have to check it, the depth of crack depth, width of the crack. Okay, whether it is surface crack, whether it is cluster crack. Okay, so that you have to know. And second one is the environmental condition. Where the structure is, in which environment, which temperature, which climate. And third one is the loading pattern. So that you also have to know, because sometimes while we are designing and when we are using the structure, so both are mismatching. So in that way, so it may be reason for failure of a structure. And fourth one is the shape and function of a structure, because in some time when we are using some purpose, designing some purpose, but we are using some another purposes. So that is known as the shape and function of a structure. And next one is the accessibility, underwater and underground or in overhead reservoir, which is any improper design or drawing. If you are follow that one improper design, okay. So if you are not taking the accessible load, so in that case, which may leads the damage of a structure. And next one is the importance of a structure. You know that whether that structure is hospital building or any building which is people is more than 400, 600 people are staying. So that is not the importance of structure, whether it is residential building or any college building, hospital building. And then next one is the time availability. So that means what is the time period is there. So it is also very, very important structure, because based on the time, so that economically will depends. Okay, because if post the shorter time, then the your cost will be less. Okay, and the aesthetical condition. Now people are very conscious regarding the aesthetical condition. Is it? So there are different kind of crack is there. Okay, types of crack. So that is known as crack assessment. So if such type of crack is there, so that is known as due to corrosion in steel. Okay. If such type of crack is there, this is known as due to shrinkage in concrete. So sometimes we are observing that there is some hair type of crack is there, and this is known as in case of column. If such crack is there, so this is known as excessive load. So that means when the section is inadequate, and the surface attack of a concrete. Okay, so if there is some soil is contaminated with the excess so which may lead the very expensive product in the concrete. So that means undesirable product. So that expensive product creates the immense stress inside the concrete, and as a result, the cracks come on the bottom of the, and this is also known as alkali aggregate reaction, because there are some aggregate is there which is very reactive in nature. Okay, or there are some water is there, or there are some admixture is there which is high amount of alkali plaster. So that crack with the help of some ultrasonic test. If any crack comes on the support of the near about support of the beam, so that is known as shear crack of the due to shear. That is shear failure of the crack. So in that case, that means your the stirrup is not adequate. So that means your stirrup is weaker. That means you are providing very wider space of stirrup. So such type of crack is coming. And in the slab or in the road, such type of very wider crack is there. So that is known as okay. So this is the picture where the plaster as well as some concrete is also come out from the rest of the concrete. So that means known as delimitation of concrete. And spelling is only surface comes out. So there is no spelling. And delimitation, that means along with plaster as well as some concrete comes out. Okay, from the rest of the concrete. So that is known as delimitation of the concrete. So here you just look it carefully that the most of the reinforcement is corroded and the volume is increases, and that volume increases creates the internal stress in the concrete, and this concrete is very less density, very lesser density. Okay, so that means the strength is not also proper, and as well as also the link spacing is very wide. Okay, so the link spacing in case of column, so that must be very closer or as per as our requirement. Okay, on the for the durability aspect of a concrete. Hmm. So that is known as swelling of a concrete. Swelling of a concrete, that means in case of concrete absorbed water. Okay, so that is known as swelling. So that is also harmful for also concrete. And there is also swelling. Only the plaster, when plaster comes separated from the rest of the concrete. And that all most of the cracks and failure due to the corrosion of reinforcement. And this is also swelling of the concrete, and sometimes there is the improper way the reinforcement we are placing. Okay, the in case of this reinforcement, this is the beam column junction where we are placing this reinforcement, so where we are not providing the sufficient cover. Okay, so in that case, so in case of insufficient cover, so that may also leads the this type of failure. So that is known as spelling of a concrete. So this is known as corrosion of a concrete. So you know the corrosion of a concrete. So this is the corrosion of a concrete, where most of the concrete uh, is delimited from the rest of the concrete, and this is the seepage. So these are the very common problem for concrete durability. This is also known as dilapidation of a concrete. Okay, so dilapidation, that means one kind of failure of a concrete where most of the concrete along with some plaster as well as inside the concrete, the which separated from the rest of the concrete. So that is known as dilapidation of a concrete. So now the repairing technique. So the selection of the repairing material, that is very important material. So that means your repairing product must be shrinkage compensation, and that must be having a good bond in between the older and the new concrete. Okay, and that must be compatible when coefficient of thermal expansion, that it is very must lower. Okay, and it has must very higher mechanical property, like it has high tensile strength. Okay, and the repairing material required, it should possess sufficient alkalinity to protect the steel embedded in concrete, as well as also it has very low air and water permeability. So the repairing product is also very important for the durability of a repair. Okay. Because repairing is very important thing, and as well as very costliest thing if you do want to do the proper repairing technique. Okay, so the cost benefit ratio in case of repair, so that must be less than 0.5. The cost benefit ratio, that means the cost of new construction divided by cost of repairing one. Okay, so that means the whatever the repairing cost, that shall not be more than 50% more than the new construction. Okay, so that's why the repair must be highly durable and highly good mechanical property. Okay, otherwise it will not durable, and as well as also resistance UV rays and non-hazardous. So that is also very important for us. So now how we can repair? So these are the repair and retrofitting Pictionary. So I am showing here. So first of all, whatever the initial crack is there, so you just try to clean it, and you just cleaning it with the help of some repairing product is there, and just and instead of just repairing matter, you just place some polymer modified mortar, so which is very non-shrinkage and very having also with some waterproofing compound, and also very high durability, as well as very good compressive strength. Okay, after that you want to do the micro concreting. So micro concreting, that means that one kind of ready mix concrete is there, having with all kind of concrete other than water. So that 15 kg bags is available on the market. So you just ready to use concrete, you just only use some amount of water which is prescribed on the product. Okay, so that gives you the high strength and high durability. So that is micro concreting, but though that concrete is much costlier, but it has high durable concrete. Okay, and before that there are some injection grouting is there, because there are some inside crack is there. So there are some needle type of structure instrument is there. So you just like injection, you just push that needle on the concrete, and you just place that cementitious repairing product. So definitely due to the high pressure, so the cementitious product will go inside the concrete, and that it will precipitate it on the portion where there are huge amount of honeycomb bees there. Okay, and there are, this is also another product that is known as carbon fiber wrapping, glass fiber wrapping. So you just confine it for re-strengthening. So these are some table that I am preparing for you, that the symptom of distress and what kind of repairing product is there and what kind of repairing material is there, because in the market there are so many repairing product is there. So you have to know the which product is usable for exact your purpose. Okay, so these are the chart so that I am preparing for you. So before that, going to that one, so these are the repairing products. So you know that the corrosion is also very harmful. So basically corrosion, it I already explained you. So when there are some steel bar is there, so steel bar basically it has rich in iron. Iron is basically cation. Okay, so that is Fe2 plus cation, positive ion is there. Okay, but in the water there are some negative ion is there, that is OH ion is there. Okay, so that is some negative electron is there. Okay, so this positive and negative ion exchange in the concrete cover. So when there are some air void is there, so on the air void, so that water, oxygen, carbon dioxide, even also some acidic environment fluid will go inside the concrete, and that will create some environment where some ionization exchange is going on. Okay, so as a result, so one is some cathode formation is there, another is some anode formation is there. In some, in the there are some alternative way, cathode anode way is going on. So the reaction basically this cation and anion reaction is going on, and as a result the these are the product formation, that is the iron as well as the oxygen. So these are basically the rust product. Okay, so this is very expensive in nature. Okay, so this is the reason so for the corrosion of reinforcement. So for high durability of a concrete, you have to make the concrete high grade of concrete or high density of a concrete, so that the top portion concrete must be denser and uh, less permeable, so that from the top of the concrete the atmosphere from the carbon dioxide, oxygen and any other product cannot go inside the concrete. So these are the product, you just know these are the before corrosion, and these are the some corrosion once started, and these are the further corrosion. So that means the volume is increases, and these are the ultimate corrosion. So that means the crack comes from inside to outside. Okay, so basically the structure which is located in the sea or any water or any tidal zone where water is continuously coming, so in that case, so there are some chances of such type of effect inside the concrete, and this is basically may leads the high amount of corrosion. Okay, so while we are going to the treatment, so you know in the market there are different kind of product is there. One is there, you have to remove the dust. Okay, cleaning, and then you have to using some, this is some rust cleaning agent is there. So there is acid based material, and then after that rust cleaning agent, then you have to do the zinc rich primer. Okay, zinc rich primer is there, and then you painted it with the help of some anti-corrosive, that is the zinc rich. So zinc is basically the anti-corrosive agent, so it absorbed high amount of that negative ion. Okay, so that means zinc basically the protect the corrosion, okay, of a reinforcement. So whatever the paint that you are using, that must be in zinc rich. Okay, more amount of zinc. So that means it gives you the better corrosive protection. Okay, so these are the protection technique. So another new technique is there. This is the galvanic anodized sheet. Okay, so what is this one? This is some there are some anode, so just we are placing inside the concrete. I'm showing you in the picture. So that is the very latest. So in case in the last 10 years ago, the Canada, they are identified such kind of technique. So in our country, so now we are using such kind of technique. So because our country is most of the failure due to corrosion. So that's why this is the technique. So in case of new construction, in case of repairing construction, so just we are placing such kind of anode. So what is the anode? So that is high alkaline and zinc base. So just when we are placing this one, and that we are connecting with the help of some wire from one reinforcement to another reinforcement. So what happens? So when some negative ion will go inside the concrete, so zinc will absorb all of this one. Okay, so that means zinc cannot increases that environment, so which may leads the corrosion. Okay, so that is known as galvanic anode shield. So that is the application mitigates incipient anode formation and to prevent reinforcement corrosion in new construction and bridge widening and slab extension, and as well as also these are the pre-stress concrete, post-tension concrete also. Okay, and that this one is very user friendly and low maintenance. Okay, and long lifetime up to 10 to 20 years. Basically, if you are providing more connectivity once to another, so that gives you the long lasting time. Okay, so basically the application, suppose this one is a reinforcement which is inside the concrete. So this one is corroded, this one is non-corroded. Okay, so this is known as chloride contaminated concrete. So when chloride contaminated concrete is there, so that it increases the corrosion. Okay, and this is the chloride free portion. Okay, so this is the potential difference, this is the portion. So one is chloride, another is without chloride. Sorry. So the portion, this is the border line. So this is the potential difference between the patch and the chloride contaminated concrete. So in this portion there are some potential differences, they are positive to negative. Okay, so in that, in this two portion, this is the two portion, this is one reinforcement, this is one reinforcement, this is another reinforcement, and this is the portion. Okay, in this portion, this is the anode portion. Okay, this is just like a one cell, small pencil cell. Okay, that we are using at our remote control. Okay, so this is just like a A33 battery, A3 plus battery cell. Okay, so that we are using. So in between these two portion, we are just placing this one. Okay, so this is known as anode galvanically protected surrounding the bar. So when we are placing this one, so when from the atmosphere any kind of carbon dioxide, fluoride comes out, this is we can have a base. So this is the portion, this is the picture. You just look this one, and this is the two wire. So these two wire are, you can connect it, you have to connect it on the two adjacent reinforcement. Okay, so this is one, this is one, this is one. So this is different type of, depending on your requirement. This is the anode galvanizing sheet. So this is very latest technique. Okay, so this is the portion. This is also very high zinc based galvanizing anode, so that we are placing. So depending on your requirement, so you have to place it. This is also very big amount. So higher high intensity of corrosion is there. That is means in case of offshore structure. So that is very big. So you can place it. Okay. So this is very also costly product. Okay, so this is, you can place it, but while you are placing, this is the wire portion, this wire, two wire portion, you have to firmly connect it on the two corroded portion. Okay, and this is also another technique similar. This previous one is the one anode system, you have to place one, and this is the technique one tablet. What kind of tablet? Just like a capsule or tablet that we are taking at our body. Okay, just like a one antibiotic tablet. So this is the picture. I don't have that much picture because in my laboratory, that is the in my department, so that small amount of tablet is there, but here I don't have any photo, so I cannot show you. So this is the tablet. So this is the similar one. So this is very small tablet. So you just place the tablet inside the concrete, or in case of repairing one, you just drill it and you just place there. So this is the similar thing. So this is known as caplet for protection of rusting steel in concrete when no other product works by the vaporizing through the concrete. Okay, so this is known as power throw. So now repairing, these are the reason. One is poor design, next one is poor construction, subsoil containment. So these are the sector. So now what are the repairing products? So first one is the epoxy grouting. So what is the epoxy grouting? So epoxy grouting is a two component low viscous high strength material. Okay, so there are two grouting is there. One is epoxy, another is cementitious grouting. So epoxy grouting, when we are using in case of, suppose any structure which is steel, heavily loaded structure, suppose any structure, any steel structure, any steel foundation. So we are just placing the concrete, and then we are placing the some steel bolt, and then we are placing some steel plate, and then we are placing the ISMB or some steel column. So in that case, the concrete can take huge amount of load. Okay, so in the bolt, so in that case, any repairing requirement is there. So in that case, so you need to require high amount of strength. So that is known as epoxy grouting. So that is costlier, and this is the advantage: free flow and chemical resistance, excellent durability, cost effective, and excellence in service performance. And it is also high compressive and flexural and tensile strength insurance, so also long durability also. Huh? So the process is very simple. So that is also in liquid form. So you just place it inside the concrete, and where the concrete crack is there, so this type of crack, so with the help of some injecting grouting, or if in wider crack is there, so you just place it easily. So no problem. Okay. So this is the portion. So portion. So you need to place some drill in the concrete. So after that, these are the some tube, small amount of 2 mm diameter tube is there. So you just place it permanently, and with the help of some pressure grouting, so you just place it on the ground. Okay, so that it can gives you the more denser and less permeability of the concrete. And in case of water leakage, so that is also very important. So that is very latest technology, that is known as polyurethane grouting. That is very high and durable grouting, because application of repairing product that must be user friendly. So polyurethane grouting, basically that one type of grouting, you just place it with the help of some pressure grouting system. So just like a painting, pressure painting system. So this is similar kind of product. Very less amount of thickness is there. So once you apply that one, so within 5 to 6 minutes, so that it gives you the very hardened property. Okay. So as a result, it can protect you the waterproofing, protect you the waterproofing system. Okay. So these are the use advantages. So rapid scaling against water, and low viscous, and very flexible. That is very important. Strong but flexible to withstand different structural movement. Because in case of water retaining structure, so water is always creating the pressure inside the concrete. So that it must be withstand that kind of pressure. Okay, that means that is known as hydrostatic pressure. Hmm. So this is the system water retaining structure. So where we are applying the pressure with the help of this instrument. So this is known as PU grouting. And sometime any old structure is there, you want to extend that structure. So in that case, you need to some adhesive bonding agent, structural bonding agent. So that is known as adhesive bonding agent. So in case of joint of a column, joint of a slab, or joint of any kind of beam, so you need to apply that epoxy bond. So that is known as adhesive bonding agent. So otherwise there is some strength differences there of old concrete and new concrete. Okay, so these are the adhesive bonding agent. Okay. So spelling I already described you. So in case of spelling, so what are the product? That is the high strength repairing mortar. So that is known as poly modified mortar. Okay. So that is shrinkage control, polymer modified, and fiber reinforced cementitious repair mortar, specially designed for spraying material. Okay. So these are the uses, cost effective, and that gives you the durability and very good compatibility and user friendly also, and it also very good durability also. And I already discussed the based grouting, and next one is the cement based mortar and polymer based mortar. So these are the type of mortar. mortar system. Okay. So cement-based mortar are most commonly used and also very low-cost repairing product for concrete repairing purpose. We are using that is known as strength, thermal expansion, UV resistance, and generally easier to work than epoxy product and cheaper than epoxy product. Okay. So these are the application. Okay. So these are the step 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the different application step so that we can use this repairing product. Okay. So next one is the jacketing technique. So how we can enlarge our section, because sometimes when we are going to repairing or we need to repair, so that case the existing concrete structure is may not be adequate because we are removing the mother of the concrete from the main concrete structure. So that purpose you need to provide the additional reinforcement as well as additional concrete. So that is known as jacketing. So while jacketing, the two things is there. One is the you have to provide the additional reinforcement and you have to provide the micro concrete. That is known as high strength, high performance, high durable concrete. Okay. So that is known as micro concrete. So that is high strength, non-shrinkage cementitious product. Okay. So this is pre-bagged to overcome site-based variation and rapid strength gain. That is the most important. High ultimate strength and contains no chloride admixture. So that is also very important. So these are the main advantages. So these are the application technique. First application is you need to do the grouting, and after grouting you need to do the protection with the help of zinc base coating of the reinforcement, and then you shuttering it, and then you place the micro concrete. Okay. So these are the concrete jacketing. So whatever the mother concrete is there, so you need to place the additional reinforcement and then you place the micro concrete. Okay. So while you are doing the micro concrete and repairing the concrete, so in that case you need to re-strengthening from the foundation also, because foundation subsequently also be much stronger with the proportionately with the superstructure. Okay. And similar way you have to providing the additional reinforcement on the basement of the foundation. Okay. So these are the some re-strengthening of the existing structure. Where existing structure you need to vertically extend it. Okay. So in that case you have to need the more amount of reinforcement as well as also the increase the sizes of frame. Okay, frames. So while you are providing the additional reinforcement, so in that case, this one is the shear key. So this shear key, the hook type, U type of shear key, you need to provide it, and you have to grip it inside the concrete. And that grip you have to fill it with the help of some adhesive bonding. So that is alternative shear key you must be provided. This is the alternative shear key. Okay, this is the shear key. This is not alternative. All shear key they are providing in all the type. Okay, so first of all, up to foundation level, that repairing is done, retrofitting is done. Then additionally they are providing the reinforcement as well as the tie, and then they are providing the micro concreting after uh, shuttering. Okay. So this is the repair, before repair, and then this is the after repair. So this is known as jacketing. Okay. Then delineation of a concrete. So why strengthening is required? You know, there's required additional level, required additional ability, change of building use wind loading, and change to design code. So these are the requirement. Loss of reinforcement. So for that purpose we require re-strengthening. So all we know that why re-strengthening is required. So sometimes there are some conventional way of repairing it technique is there, but sometimes there are some slab is there, some crack is there. So that also need to be repaired. Okay, because that also because in some slab is there, that is not the not beam slab columns. That may also may the flat slab is there, which is beamless slab. So in that case, or there are some there are some bridge is there, which is the slab having with some beam. That is beamless deck slab. That means the thickness is more. So in that case, so you have to use such kind of repairing product so that it can be sustainable. Okay. So that's why this is the product. So that is known as fiber reinforced technique. Okay. So that means polymer plus fiber. Okay, that is known as 5R reinforced polymer technique. So one is 5R, next one is polymer. So that is known as 5R based polymer repairing method. Okay, so 5R can be oriented to provide properties in direction of primary level, and these are the resins. Okay, so these are the common fiber. One is carbon fiber, another is glass fiber, and third one is the ceramic fiber. So this is the carbon fiber. Basically, carbon fiber is very high tensile, high stiffness, and high tensile strength, low ultimate strain, and high durability, and it can also the withstand the uh, low thermal expansion. Okay, so these are the thermal. These are the carbon fiber. So carbon fiber is basically two type. One is uh, one direction, another is multiple direction. That means this is the carbon, so that carbon is placed on both the direction, that is both direction. And some carbon, this is the carbon, this is in one direction, carbon is there, another direction no carbon, only fiber is there. So that is the one direction, this is the bi-direction. So bi-direction, that gives you the more strength, more stiffness. Okay, so this is the one direction, that is the bi-direction. So we are wrapping the beam and column or slab. So this is the orientation of fiber. So this is the column that we are wrapped it. So while we are wrapping, so that means we are increasing the stiffness of a column, nothing more. Okay. So just like our leg, so when our bone has broken, so in that case, doctor advised to do the plaster. Okay, so why plaster? Because there is gypsum plaster of Paris they are providing. So that similar kind of technique that we are providing. So that means while doctor is plastering our knee, so that means his intention is to increase the stiffness of my leg. Okay, so this is the also similar kind of aim of uh, uh, the column, so that we can increase the stiffness. Okay, so this is the scheme. So there are different kind of crack may be there. So based on that way, so you have to place the fiber. So that means in the corner portion, suppose in concrete column, so that means there are some 90-degree corner is there. So that fiber you can bend it in any shape. So that means it has high flexibility. Okay. So these are the one breeze, so that you can repair it of all the component like PR, abutment, as well as girder, back slab, and both the way you can protect your breeze for as well as also seismic upgradation, column strengthening, and negative moment strengthening. You can repair it. Okay. So this is one building. So such type of FRP, uh, fiber reinforced strengthening of building were done. So that is the column, and that is the slab, and as well as also the beam portion. So you just wrap it, and while you are wrapping, you need to provide some adhesive. Okay. So these are the different kind of application technique. So while we are doing the repairing. So normally in breeze construction, breeze structure, so we are recommending such kind of uh, technique. So this is the after repair. So just that basically gives you the uh, more stiffness. Okay, and as a result, it gives you the more load carrying capacity. Then you painted it, so it is similar, almost similar to the new construction. So many more project is going in our country. Even also I am involved in so many projects at National Highway Authority of India at our country. So where we are doing such kind of assessment, and where we are involving such kind of technique also. So this is the slab re-strengthening. So slab re-strengthening, this is the technique. So in case of slab, so how we can apply similar kind of technique. Okay. So in case of slab repairing, so if there are some crack is there, so this kind of fiber strip, if you place just perpendicular to the direction of the crack, so that it can reduce the increases the crack uh, thickness. Okay, and as well as also it can gives you the more load carrying capacity if you apply the fiber strip perpendicular to the direction of the crack. So you know the shear crack and flexural crack. So this is the any beam. So this is the zone 1, zone 2, zone 3. So in the zone 2, so the such type of crack normally which comes around the support of the beam, so which is known as shear crack. And the middle portion, this is known as flexural crack. So if you go closer on that one, so you can measure the width of the crack and depth of the crack. So once you have that one, so then you have to follow the what kind of repairing technique. So this is the suppose crack. So after perpendicular direction, you have to do another crack, okay, artificially. And after that, this is the carbon strip, okay, and then you place this carbon strip perpendicular to the direction of the strip, and then you place it, cover it with the help of some epoxy grouting. That is basically one kind of stitching technique, concrete stitching technique, okay, with the help of some fiber strip. So this is the crack. So you have to uh, do more wider on the crack, and you have to clean the crack, okay, and perpendicular direction you have to cut it in perpendicular direction, okay, you have to cut it, and then you have to measure that how much length is there, how much your repairing material is there, up to that much length you have to cut it, and on the perpendicular direction you have to place it, okay, you cut it, okay, up to certain interval. And this is basically ultimately one kind of switching of slab. Okay. And then you epoxy grouting it, you painted it, okay. So these are the symptom of distress: corrosion of reinforcement, structural repair, then the repairing method, and the repairing material, okay, what kind of material that we have to use, okay. So these are the different kind of all kind of which I have covered most of the type of symptom of distress and repairing method. And these are some type of product, that is anchor grout, shear clay, ready mix plaster, ready mix mortar, tiles adhesive. So these are the repairing also material, okay. And this is very important advanced waterproofing system. So so that is most of the epoxy compound and polyurethane based, okay, polymer emulsion and cementitious polymer based. So these are the waterproofing, like in the roof treatment. So we need to earlier time people were used the bituminous coating, membrane, and water based some loose concrete that we are providing with the help of some jama brick. So this is very oldest technique. So now after that the bituminous coating came. Okay, so now after that the polyethylene membrane has come, and then the epoxy coating, and then now the latest technique, that is polyurethane film is there. So that is very less thickness. Okay, so this is the very oldest technique, and this is very APP membrane. Now people are widely using. This is also one kind of technique. Okay, and this is also cementitious coating, waterproofing, and this is also epoxy based coating, that is also very lighter thickness and smooth finisher, high durability, and this is also known as polyurethane based. This is also very lighter and very latest and advanced technique. Okay, and this is one kind of just like a very visible clip there. So above the concrete. Okay. So this is my presentation. So I hope that you will enjoy, because in the presentation you know that I am trying to cover most of the things, because it's a very vast subject. So it is not possible within shortened time to cover all of the things, because I have involved so many more projects in our country. So based on that way, I am preparing my presentation. So as per my advice based on this presentation, I am telling you that before going to any repairing work, just try to know what are the reason of symptom. Okay, what are the reason of distress? then you can do the type of repairing technique. So thank you once again, all the patients, all the participants for your kind patience, for spending your most valuable time with me, and thank you all the organizer uh, to giving me the opportunity to sharing my knowledge with you. Thank you.
Thank you, sir, for your informative and interesting deliberation on topic repair and retrofitting of existing damaged structures. We, the faculty members of Haldia Institute of Technology, as well as all our participants, are very, very happy and overwhelmed with this session. Professor Partha Ghosh has discussed important points and aspects of repair and retrofitting techniques. In this discussion, Sir has discussed how to observe the damaged structure before deciding on the techniques of retrofitting. What are the in situ evaluation of load-bearing structures? Sir discussed about the permeability assessment of concrete, under which Sir explained all the tests in detail with pictorial representation so that we could see all the equipment used for assessment. How to assess the tensile and bond strength of concrete, how concrete temperature monitoring is done using thermocouple, condition assessment of reinforced concrete structures using automated robotic multi-sensor system. Sir clearly made a point that as a civil engineer, we can repair a structure only when we know the reason of distress. Sir explained about corrosion in reinforcement and techniques to avoid corrosion. Of all the discussions, crack assessment was my favorite because where you have shown the pictures of different concrete distresses and the repair materials used in the reinforcement in the retrofitting. I think this detailed discussion will help our participants to enhance their knowledge in repair and retrofitting. So, your presentation was very well organized and detailed with understandable language and all the real time images which attracted everyone. So, once again, on behalf of the organizing committee, I'm thanking you, sir, for this important discussion. Thank you very much.
Thank you, ma'am. Thank you. Thank you for your feedback.
Now, I would like to pass on to Dr. Atrey Bandupatya, who will be asking the questions posted on the by the participants in the chat box. Over to you, ma'am.
Thank you, ma'am, and thank you, sir, for your wonderful, interesting presentation. So, if I may ask, any of the in-house faculty have any queries regarding the same, then please they may ask now. Otherwise, I will move to the other participants. They have some questions. So,
Sir, thank you, sir. It was very explorative and informative presentation. And thank you for, we are very grateful that you have taken time and given us such a lecture in repair and retrofitting of concrete structure. So actually, I have a question. Sir, basically, if there is a column which has been damaged, the strain capacity has not been there in a ground floor in the middle of the building. So, should we go for jacketing or retrofitting, or should we also place a supporting column beside this column, or we just go for retrofitting and or jacketing for that column?
Okay, thank you for the question. So actually, in case of such type of problem, we know that in our country, so most of the building, even also where I am staying the building, so most of the building ground floor is empty that we are providing for parking purpose. So in that case, such type of building is much more vulnerable for damages because it is due to the sub-story effect. Okay, but there is no option, so we have to provide it the ground floor for parking. So in that case, so you have to provide the such type of technique, that is the corner column you must be provided in L shape. So otherwise, so it is very difficult to affect the substory effect. Okay, so this is the problem. But if such problem comes, so now how is the solution? So this is the question. So
So
in
yes,
that
sir,
case,
in the middle of the ground floor.
so I know. So in that case, so normally, so in case of the in such type of that is very rare because in most of the column that we are facing problem that is on the ground floor, but medium floor there is no problem because if you do the middle pour through jacketing or any kind of technique, so that means the middle pour will be much more steeper with comparing to other floors. So that is also not allowable as per IS code. Okay, because in case of repairing, so that means when we are steepening or in case of we are jacketing the column, that means we are steepening the structure. Steepening the you are increasing the stiffness of the column. So
Yes.
that means the inter-story
Flexibility
the
will
stiffness,
reduce.
yeah, inter-story the stiffness
Hmm.
difference will be
Have.
more than 30%.
Yes.
Okay, so that is not allowable as per IS code. So that is not recommended. So in case of repairing purpose, so we are recommended that while you are repairing for column, at least 50% of the column must be stiffened. Otherwise, there will be some stiffness difference from one to another. Okay, so that is also very dangerous for your case. So in that case, so I think you do the minor repairing. Okay, you don't do the jacketing, you don't do the any carbon rating. Okay, so this is my suggestion.
So basically, if the column is failed in compressive strength capacity, then means minor repairing is okay.
No, in the okay. So in that case, you have to do the strength assessment. So what is the intensity of corrosion? What is the exact composite strength of concrete? And what are the condition of other floors? So you have to do the proper survey. Okay. So based on that way, you have to do the repair. So if you have any problem, so other than this platform, you can take my mobile number. You can send me the picture, so I can guide you as per my knowledge. Okay.
Sir, actually, what I have seen, most of the nowadays the ground floors are vacant only. Those are parking areas. But most of the old buildings, which are residential buildings, where there were no parking areas in the ground floor.
No, no.
What?
Well, I know this is the big problem, I think. So I think you can talk me later on because
Okay,
what
okay.
are the picture on the present position? So you send me through WhatsApp because I have to see the picture.
Yes.
Because without my behavioral knowledge, so it is very much impossible to give you the exact solution.
Okay, sir.
Okay.
Yeah,
Whatever the
thank you, sir.
picture is, yes.
Okay, sir.
Thank you.
Sir, actually, I have another question also. Sir, regarding offshore structures, normally what type of corrosion are predominant? Like chloride corrosion is there,
Chloride.
sulfur or salt
No,
chloride
no, no, no.
corrosion?
The chloride.
Okay,
Sulfur corrosion is very rare. Basically, sulfur is not reason for the corrosion of a concrete. Basically, in presence of sulfur, there are another product formation, the presence of water, okay, in presence of water as well as also soil. So the most of the reinforcement corroded, so which are mostly due to the corrosion of the reinforcement and as a result of the chloride of the concrete, not the sulfur of the concrete.
okay. And sir, also the salt water, will it do any effect in the concrete because of the salt in the water? Sir, salt water,
Pardon?
because of the salt present in the water in offshore structures.
Definitely, definitely. Salt is also harmful because in case of alkalinity will changes. Okay, your alkalinity will changes. So high alkalinity is also not desirable for making durability aspect of the concrete. Okay, so in that case, if the high alkalinity is there, you have to check the alkalinity of the water. Then you have to provide the protective coating on the concrete on that particular area. Okay.
Thank you, sir. Thank you so much. Yes, ma'am. I have no further questions.
Thank you, ma'am, and thank you, sir. Anyone else from the faculty? Do you have any query? Okay. So no one have any query from the faculty. So let us move to the participants. Sir, there is a question from Kashivatna Murthy, sir. How do we balance the strength of concrete while adding these chemical substances? If you may clear the question.
No, balancing the structure, first of all, while we are making the structure, so concrete is so many composite material. Concrete is very composite material. So while you are making the concrete, you have to careful all the parameters, source of the material as well as the mixing of property of the material. and the proper water cement ratio, proper grade of concrete, proper curing of concrete, proper mixing of concrete, and apart from that, the workability of a concrete. So workability of a concrete, so that is also very very important, because people are not aware regarding the proper quality and proper quantity of admixture. So suppose sometime you need to water reducing admixture. In that time, people are using the water reducing admixture. So you have to know, because all admixture have not the all not gives you the all kind of property. One admixture have give you the one kind of property, hardly two give kind of property. But depending on your the structure, where the structure is situated, and for which purpose you are using, so based on that way you have to select your waterproofing compound or water reducing compound or any accelerated curing compound. So this is the main thing. So based on that way you have to select this admixture. Otherwise, so your workability of the concrete, so that means that is there is no value. So ultimately, so you cannot make the proper quality of a concrete. So whatever the target strength is there, you cannot fulfill it, and you cannot make the proper durable concrete also. So that's why while you are making the concrete, the selection of a material, source of a material, and quantity and quality of a material is very very important. So you have to ensure it. So before making the concrete, you make sure again and again, and if necessary, you do it the pre-checkup, like the quality of the aggregate,
Trial mixes.
quality of the cement, etc. Okay, quality of that mixer. Okay.
Thank you, sir. I hope this fulfills the question and query asked by Mr. Mukti. Now, another one question is there by Mr. Arpan Maiti. What is the quickest way to check the strength of an existing old building?
Actually, you have to use the micro concrete that gives you the strength within 1 day. For concrete is a substitute of concrete, normal concrete, you have to use the micro concrete. Okay, and substitute of mortar, you use the polymer modified mortar. That gives you the quick setting time, quick strength also. Okay, and high durability is also. And apart from that, for normal new construction purpose, the quick setting cement is also be there, and quick plaster is also be there. So you can use such kind of structure, so that gives you the quick
Sir,
strength.
if I may, the question is asked on an existing building to check the strength of an existing building. I think the conventional methods that we use, hammer test and all, this is the answer, or maybe something else you can suggest if
No, existing method, that are two method is there. One is destructive, another is non-destructive.
non-destructive of VNDT and
Test, there are Smith hammer ultrasonic test is there.
yes,
Windsor is there. In my presentation,
yes,
there are more
yes,
implementation.
yes, 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 yes,
Destructive test, there is court test is there.
yes.
You can
No, so
check.
the question is was that what is the quickest one of all of them for an existing old building to check the strength?
Capo test, cut and pull out test, capo test.
Okay. Thank you, sir. Sir, I personally have one question. Sir,
Yes.
if there is a structure which is degraded and we need to retrofit or enhance the structure to its glorious form, so is it possible to glorify the structure and upgrade it to this to its to its older form in consideration of their strength and ductility? Because for earthquake prone areas, retrofitting can be an solution for the structures, safe and ductile also. And how can we measure that after retrofitting?
No, actually there are different kind of ductility product is there. Suppose in heritage structure, now we are using one kind of chicken mesh is there. So while we are plastering, normal plastering, removing the normal plaster and we are using the chicken mesh, then we are plastering. So in this way we are strengthening many more structure at Sikkim and Nepal also. Okay, I have another presentation, because today I don't have any time, so that I cannot show you the what are the seismic retrofitting technique is there. But technique
Okay.
is there, product is there, so everything is possible. Okay.
Thank you, sir. Thank you for your awesome and so much interesting presentation. Thank you.
Thank you.
It helped a lot. Thank you, sir.
Okay.
Now, I thank all the participants for their responses and their presence. Dear participants, please note that our next session will start tomorrow at 11 a.m. It will be a very interesting lecture on the topic of feasibility study of manufacturing refractory and acid resistance from brick industrial waste, presented by Dr. Amir Kumar Shamanto from NIT Durgapur. Please join tomorrow's session 5 minutes before the scheduled time. With this, we come to an end of second day of our 5-day online FGV program. on the topic of recent trends in civil engineering. Thank you and have a great day ahead.